Thank you so much for the raid, Matt. Let's try that again. Welcome to the stream. I'm still getting things set up a little bit. You caught me on my back foot, but very much welcome. Today what we're going to be doing is doing some Go programming on CockroachDB. We're going to be looking at whether we can see if we can add some always-on performance counters to the database. And the music is currently way too loud in my headphones. Let me turn that down just a tad. Just a tad. You guys probably can't hear it. Let's do... Man, I gotta say that monitoring 2 levels at once is kind of a pain in the butt. But in any case, I hope you're all doing well. Matt, how was your stream? Did you guys accomplish a lot of Prometheus goodness? I hope you did. I hope you sure did. So let me switch on over to the old desktop view in a little bit here. Make the font nice and big for everyone. Look at that. That's a big font. Cool. All right, so here's what we're gonna start out doing, you guys. We're gonna take a look at what we do already in CockroachDB for analyzing the performance of various queries. We have a lot of cool stuff. I think it's pretty fun to do, even if you're not like a CockroachDB aficionado. There's some interesting things to learn here about just the way that you can track what a piece of complicated software is doing at any given moment. I don't know. If you're all Go heads, you're probably used to using pprof. And so we do have kind of like a pretty nifty pprof integration that I wanted to try to take a look at as the first thing that we do. And yeah, so there's kind of 2 things, right? There's our pprof integration, and then there's sort of this per query explain analyze thing, which is pretty neat. It kind of gives you like for every stage of a query, how much CPU resources or memory was used at each of these stages. So actually, why don't I just start out by showing that off, just to get the brain flowing. So I'm going to start up a Cockroach server here. And I'm just going to go ahead and run like a super basic workload on it that does something just not so complicated. I'm going to have it run just kind of some read-only queries against a simple schema that has a key and a value in it. And we can kind of look at what's happening there. Does it do explain for each node? It does. I'm going to show that off in a second. But first I'm just going to show kind of this pprof mode, because I think it's, I don't know, just a good way to start thinking about things. So if I run, there's a bunch of workloads sort of built in to the binary here. So if I say cockroach workload init kv, and then cockroach workload run kv, I think this is going to give me a workload that's running just as many queries per second as it can. Some like a mix of writes and reads against the database. And so that's cool. I'm just going to let it kind of do that. And at the same time, I'm going to go and pull a pprof from the server, which I'm sure you're familiar with doing this if you're like a Go person. What we did is we built this pprof server into our binary, so you can always run it at any time, which is kind of nice. With this Go tool pprof thing, which I guess I don't have in my bash history since it's been a bit since I've done that. So what I'll do is I guess I get to show off something else, which is kind of neat. I'll go to our web UI here. And if you go to this advanced debug page, you're going to get a URL somewhere that's kind of this pprof URL. And that's what we're going to use to grab this profile. So I'll grab that and come back into the terminal and use go tool pprof. If you haven't checked this out, I mean, you really owe it to yourself to learn about pprof, because it's, whoops, I think I need to single quote this thing. It's just one of the most powerful tools. Beck Aurora, good luck today, Jordan. Thank you so much for the good luck from my lovely girlfriend who's in the other room. Thank you, Becca. All right, so after I've collected this profile, there's a couple of things you can do. You can kind of see what are the top, I don't know if you've seen pprof, right? Like let's start with this web interface. It's a bit easier to understand. The old boxes, every box and node chart is like what we like to call it. in these parts, in this household, the every box of node. So what this is going to tell you is for each of the points in a stack of a Go routine stack, in a sense, what is using the CPU for a particular time slice, right? So what we did is we fetched 5 seconds of samples. And the way that the sampler works is that it every like 10 milliseconds, I think it is, it's gonna collect the stacks for every single Go routine in the system and write down using counters how many times it sees a particular Go routine on a particular part of the stack. And it uses that information to assemble this sort of heat map. The redder the box, the more Go routines are sitting on that part of the stack. Hey, 1:40 a.m., thank you so much for the follow. So you can see in this particular case, yo, Bro Hanser, what's up? How you doing? Welcome to the stream.
Computer's hooked into over 1,000 databases.
Yoda Droid, thank you for the follow. You can see in this particular profile, it looks like the redness, which is the heatness, kind of goes all the way down to the bottom. Yo, Becca, thank you so much for that follow. What's up? I am Jay Ching. How's it going? Welcome, everybody. This is going to be a fun stream today. I can tell. This is just so much high energy in the chat right now. It's feeling exciting. Feeling real exciting. All right, so here's the point, though. Here's the point. Let's say you're a person who's trying to understand why their database is running slowly, right? Yo, Portuguese Captain, what's poppin'? How's it going? Hey, guys. What you're going to want to do is pull one of these things in the middle and try to see, like, hey, what is the database doing? Why is it using time? Where is it using time? What does it mean that it's spending time in syscall or whatever? And the truth is that if you're running a big workload with like 20 different queries going on, or maybe like 200 different queries or 1,000 different queries going on, there's going to be no real way to piece apart from this information which query is doing the badness. So this is like a big aggregate profile, right? It's like you're tracking all of the work across all of the queries in the system without regard to which is the sort of bad boy or bad girl query. I don't know if queries have gender, but if they do, then so be it. But anyway, yeah, so this is like one technique. It's good, but limited. That's kind of my point here. The other thing that I wanted to check out, can we break 50 viewers? I don't know. It's possible. If you bring the hype, you know, bring all that energy and do something with that energy, maybe we can do it. I don't know. All right, so here's the thing. If you wanted to figure out an individual query's performance profile, on the other hand, we do have this other method that I want to show you, which is called explain analyze, which is another thing that you might be familiar with, maybe if you've used other databases like Postgres. I think we kind of copy this idea from Postgres, as we do for many things, to be perfectly honest. But if you open a Cockroach shell, and let's see, I guess I have to use KV. Let's say I wanted to figure out, like, what is the database doing? Dude, am I Andy Sandberg? That's like borderline, dude. I don't know. I'm not him, but that's a borderline question. I don't even know what to say. You think the only time you ever broke 50 is when you co-streamed with Michael Stoppelberg. That guy is just a legend. It makes sense that you might have broken that with the legend of Stoppelberg. All right, so let's say we just decided to do like a big union query, like show, let's see. So select star from KV, union all, select star from KV. Let's do, so we're just like doubling the amount of data in this KV table, first of all. And then on top of that, let's do something like kind of obnoxious, like try to take all of the distinct bytes or something like that. Something that's like going to take a little bit of effort for the database to do. So we'll say select distinct V from select star from da 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 da, and then let's like do something like, I don't know. We could just maybe take the count of all this stuff. Select count star from, and then pass this whole thing into a subquery. Okay. All right. Well, that was actually pretty fast. Maybe we need to insert more data into the database for this to be exciting. Well, it took 150 milliseconds. We can still maybe get some interesting stuff from an explain analyze here. So I guess the first thing that I would usually do in this situation before I run explain analyze is just run an ordinary explain. So we'll do that and sort of see what's going on. What does the database do? Yo, Renrock2, you realize you know nothing, Tears? You can learn this stuff. I believe in you. Just keep watching. That's my message to you. Just keep watching. You're running, this is like you're using a SQL database. You're going to learn about explain. You got this. Where do you recommend studying Go, assuming proper background in
Computers
programming
hooked into
and
over 1,000
concurrency?
data banks throughout
I think
the
the
world.
very best place to learn about Go or on Berry is the Go website. The Go website just has this fantastic tutorial about Go that you can get and read about. That might sound a little bit patronizing, but I swear it's not. It's got a fantastic tutorial. That is really the best way to learn Go, in my opinion. Yo, 5 Weird. Go by example? I've never seen that, but that seems pretty cool. All right, so check this out, though. Check this out. This little chart here is a tree of what the database is doing in this query. And it's, once you learn to read this thing, I think it's pretty straightforward. What we're doing is we're scanning the whole KV table and feeding the results of that into this parent operator here, append. So what that means is that an append in this case, I don't know why we call it that, but it's essentially this sort of union everything together from both sides of its input. And for example, if I added another union all, I'll do that just for the purposes of example here. So I'll say union all select star from KV. You can see if you have 3 unions together, then like you can notice that append is kind of like a binary operator in a sense. It always takes 2 inputs. And the way the planner deals with this is it's going to plan an append at the bottom that takes both of the scans, and then append right above that that takes the input of, or the output of the first append and the input of another scan. So anyway, the point is just that like you can see the way that like data flows through this system. It comes from an operator out into its parent. Anyway, so after all these appends, we asked to take all of the distinct values of V, which is just a bytes column. And so we do that using this distinct operator here. And it says you can sort of try to figure out what it means here. Distinct on V means that it's, well, taking, that's the particular column that it's distinctifying on, in a sense. There's a render operator, which is another word for this is a projection operator. It's asking for just a particular set of columns from the query. And then we have a group by on top. The reason that there's a group by at all is that it turns out that if you want to do something like an aggregate, even though you're not using the keywords group by, it's like sort of the same operation. So we're doing a group by to keep track of what this count thing is up to. Is the append left or right associative? That's a good question. I don't know. In different Ghost, is explain a real command on in CockroachDB? Explain is like, it's a pretty common thing to see this in most SQL databases. I'm not quite sure I know what you mean, but most databases do have explain, if that's what you're asking. Okay, so here's where we're going to take it to the next level, though. We're going to ask for explain analyze on a query. So I'm going to run this again. And instead of dumping me out text, it dumps me out this big fat URL. And so we're going to go ahead and click that. And what that's going to give us is another kind of chart, suspiciously similar, I will say, to the one that we were looking at earlier, the pprof graph. And that's because, well, trees always sort of look the same when you graph them out, I guess. Hey, Yazoo, thank you for the follow. So let's talk about what this stuff is about. One kind of funny quirk that you'll probably notice that's so fucking cool. Yeah, I think so too. I think it's pretty neat. One thing that you'll notice is that compared to the tree that we saw on the console, so I'll pull that up on the side so we can compare the two together. If I can. Can I do that? Or is it gonna like, hold on. I'm gonna make this window smaller. I really need to get better at like window management. Make this smaller. You can see the tree here, and then hopefully we can also see the tree over here. So you can sort of see the two side by side, more or less. One thing that you'll notice is that the scans here, they correspond to the table readers on top here, and you can see that they're actually in opposite order. So in the text format, we go sort of bottom to top, if you think of like the way the data is flowing. And in the graphical form, we actually go top to bottom. I don't know why this is done. It's just sort of the way it is. Spiral ham. Woodford cold steaks. I don't know what that's about. I'm gonna ignore it. All right, but anyway, so you can see some interesting things. I'm gonna go through them. We start with these table readers just like before. We feed into these no-op processors. which these sort of act as those appends for reasons that I'll get into a little bit. We feed into a distinct processor, which corresponds to the distinct processor over here. And then finally, we feed into this aggregator, which is doing the count rows thing. And what's kind of funny about this is just totally a stupid aside, but for some reason, the visualizer we use for this is like a wobbly visualizer. So if you feel like a little bored, you can grab one of these nodes and shake them about, rearrange the tree a little bit. I don't know. This is really, really silly, but I kind of like it. You were getting some interesting trolls in your channel. That's pretty hilarious. Twitch is definitely weird. Okay, so here's the thing I really wanted to show you guys though, and it's actually super, super cool. So if you look at any of these boxes, for example, this table reader box, we can zoom in on it. It's going to give us some extra statistics about what the database is actually doing when it's doing the operation. So in this case, we know that it's reading from the primary index of this KV table. We can sort of ignore this spans thing for a second. Out, we can sort of ignore, but here's some new information. It's telling us how many batches got output from the operator. It's telling me how many tuples got output from the operator. Tuples is another word for rows. It's telling me the selectivity of an operator, which means how many rows were filtered out. Or do I have that backward? It's the ratio of rows that were let through to the rows that weren't, to the total number of rows. Right, so if I have a selectivity of 1.0, it means that every row that I had from my input got output. And if I have a selectivity of 0, it means that I filtered all of those rows and I didn't output anything. I'm actually a little bit confused why this is 0.99, to be honest. This might be like a rounding error or something like that. Yo, 50 viewers. Thank you guys so much for hanging out with me. This is, I think, definitely a new record for my channel. Welcome, everybody. I'm an engineer at Cockroach Labs. We're looking at database stuff. I hope you enjoy your time here talking about performance statistics in the database. So I don't understand why this isn't 1.0. I would expect that this table reader is outputting every single tuple that it gets in. I think this might be sort of a rounding thing, so I'll sort of ignore it for now. And then there's lastly this stall time business, which essentially means how much time did this particular box have to wait for its parents to finish, or its children, I guess, is really what it is. But in this diagram, it's sort of the things above it. And interestingly, there's some analogs here, right? If I look at this graph and I compare it to this pprof graph, they're sort of trying to say a similar thing. In each box in the pprof, it's telling me how much CPU time was spent in this particular box, as opposed to all of the children of this particular box. In this case, this random box that I'm having to be looking at is saying that it didn't spend any time itself, and it spent 0.8 seconds in its children. So everything kind of below here. And that's kind of what this stall time is trying to show. It's like, how much time did this table reader do, as opposed to whatever its parents are. In this case, its parents are really reading from the disk. So that's sort of like a weird case. But let's look at a better case would be maybe... Oh yeah, I forgot we also changed stall time to execution time for some of these operators. Anyway, so this is a good example. The execution time of the distinct operator here was 18 milliseconds. And if we were nice, we would show also how much time was spent in the children. So all of the things above it. We're not that nice. I would like to fix that at some point, but we haven't. But the point is there's an analog here. The execution time here is the analog of this first number here in the pprof graph. So just kind of a neat thing. Great. And then at the bottom, here's a good example of selectivity in action, right? It's like what we did is we asked the database to give us only those rows that had a unique value in one of the columns. If we go back to our query, we said, that's like unreadable for some reason. We said, explain select count star from select distinct v from, and v happens to be a bytes column. So we're asking for just those rows that have a unique value inside of this v column. Our table looks like this, show create kv. So give me all of those rows that have a unique v. Let me actually show you some data in this table just for fun. So select star from kv limit 10. It looks like we've got some integer keys on the left and some bytes values on the right with just like basically just 1 byte, I think. So give me all of the distinct 1 byte values in this table. And it turns out that since we have a selectivity of 0.25 according to this distinct operator, it means that we had 1/4 of the values have unique values. I don't know. I mean, does that make sense? I think it kind of makes sense. It's getting 295,000 values in, and the ones that it's outputting are... Now hold on a minute. You guys, I'm actually slightly confused about this selectivity operator. Now that I say it out loud, this doesn't really quite make that much sense. Check this out. So this operator is saying it's giving me 300,000 rows, and the selectivity here is 0.25, and yet the number of tuples that it's outputting is 256. That seems very wrong. Actually, you know, I kind of want to dig into that for a second. Doesn't selectivity describe the variety of values? The more indifferent values, the higher the selectivity, and the better an index might work for filtering. I think in general, you might be right about that. The way that we're using the word here was supposed to be like the actual value of the selectivity. I think it's distincting. Yeah, it is distincting. Is that an estimate? I don't think it is an estimate, but we can dive into this right now. And this is hopefully going to be a good intro into what we're going to try to accomplish today, hopefully. So let's see. Basically, the first thing I want to do is figure out where we write down this selectivity estimate. So how am I going to do that? Maybe I can just search for selectivity. Maybe that will help us. So this is looking relevant. So I know that there's this object called vectorized stats that keeps track of these statistics per operator. And it looks like the way that we calculate selectivity is that we take the number of tuples in our stats and we divide it by the batch size times the number of batches. And presumably this is the number of batches that we got in, right? So for example, if we saw, let's see, I guess I'm sort of confused for a second about like whether this num tuples thing is the things that we got in or the things that we output. If it was output,
The computer's hooked into over 1,000.
it's got to have to do with the things that we get in, right? Yo, Asher991, thank you so much for the follow. Let's actually just see where we populate these things. I don't know. I have to refresh my memory on how this works, you guys, to be perfectly honest. I haven't looked at it in quite a while. So, right. So we have this thing called vectorized stats collector. And by the way, let me actually show off one more quick thing here, which is that if I run the same query using a different form of explain called explain vec, that's going to give me all of the what we call vectorized operators that are used for this query. So it's slightly different from the sort of logical operators that we saw in the ordinary explain. These are sort of logical operators, and these are sort of physical operators. And I think that the way this stuff works is that in between, if you ask for explain analyze, in between every operator, we actually insert a special vectorized stats collector operator that just counts these statistics. And I think that that's what this thing is doing. It's sort of saying, give me everything from my input, count a bunch of statistics about it, and then pass the output, pass the input that I got to the things below me. So let's read what the code does. It's saying, ask for my input, get the next batch from my input operator here. It's
Computers
saying,
hooked into over 1,000 data banks throughout the world.
Yo, Rashor, thank you for the follow. If I got a non-zero number of tuples from my input, then I'm going to add 1 to the number of batches that I've got. So this is sort of like the input statistics, I guess. It's like how many num batches really means how many batches I got from my input. I'm going to write that down actually because I feel like this really should be documented in our proto buff. So that's stats.proto. I'm really going to write down like num tuples is the number of tuples that this stats collector received from its input. And it's the same thing with num batches. Number of batches that this stats collector received from its input. I kind of want to document the rest of this stuff too, but I'll do that later. Cool. So we've got that information. And that's all it is. I suppose that we just keep running this over and over until the operator's finished. And then the next question, right, is like, how are we calculating that selectivity? So where was that again? That was in here. It's when I ask for stats. So I guess I can call stats on this stats operator, and it's going to give me back a map of all of the information that I've collected about the statistics of this thing. And so what selectivity is calculated as is it's saying the number of tuples that I received divided by the number of batches I received. Maybe this is saying something slightly different from what I was explaining to you guys, actually. Like, so for example, I think it's sort of measuring the selectivity of the parent, if anything. So for example, like, I know I got out 256 tuples. Oh, you know what's kind of interesting, by the way, is that, like, of course we got exactly 256 tuples because all of these values are a single byte, and there's only 256 of those. So this is just saying we saw all of the byte values, all of the possible byte values from our distinct operator. Makes sense. Seems like things are generally working in that regard. All right, but anyway, so if we got 256 tuples and we divided that by the number of batches we saw, which was 291, and we multiplied that by the batch size, which is the number of tuples per batch, what is that? Who can do math in their head? It's not me. Not me in the slightest. So we'll say 256 times, what was it? Or divided by 291 times 1024. Ah, can I even type is another question. So, I mean, like, this number has nothing to do with 0.25. So I'm a little bit perplexed, huh? It doesn't make all that much sense. This is the number I was expecting to see, like a small amount of selectivity, right? Because it means that our distinct operator basically filtered most things out. You know, here's what I think. I bet, yeah. I think that it's just we're sort of misreporting. Like, the selectivity here is really what I was assuming was the selectivity here. In other words, like, the distinct operator is extremely selective in this case. It's saying out of all, you know, 291 times 1024 tuples that I saw, out of all 300,000 tuples, I've only outputted 256. So that's approximately 0. So it's sort of like we just need to shift these selectivities upwards a bit to make this make a lot of sense. Anyway, I don't know. This is like a huge tangent, to be honest. But I think it's pretty important to get this stuff right. So what other stats do we collect, by the way? We write down you know, I think that there's just like a slight conceptual mismatch here, because this is saying that I'm returning a map that says how many batches I output, but this is seeming to be kind of a lie. No, it's a little bit weird. It's sort of like we get these two right. We get batches output right, and we get tuples output right, but we get selectivity wrong. Which is a little bit mysterious. So hold on a minute. Maybe actually what's happening is that what I said earlier was slightly incorrect. Maybe like when I increment num batches here, this is actually this thing is actually wrapping not the input to a processor or an operator, but an operator itself. Yo, Golden Me, what's up? I think my project's a bit out of date. I'm actually going to update that. Thanks for the reminder. I'm going to say fans edit project, prototyping, more continuously collected performance statistics for CockroachDB. Right now, I mean, to be perfectly honest, we're like kind of in bug hunting or / maybe just understanding the current status of the code mode, which is a pretty important part before you start a project. I would say in general, try to understand what's there. It's good advice. Yo, Tava Dev, thank you so much for the follow. So yeah, basically though, I'm a little bit perplexed though about this thing. And Golden Me, thank you for the follow as well.
Computers hooked into over 1,000 data banks throughout the world.
So yeah, actually, let's go back and think about this again. Since we know that so let me actually edit my documentation too. So this is not the number of batches that the stats collector received from its input. It's actually more precisely the number of batches that this stats collector observed its operator to output, in a sense. Something like that. 256 times divided by 1 times 1024 is equal to 0.25. That is true. I think, right. Ah, that's a great point. So essentially the issue is that instead of combining the rows that we output with the rows that we got as input, we're combining the rows that we're outputting with the number of batches that we output, which is, I mean, that's almost meaningless. So, okay, actually this is a good time to take a step back and talk quickly about this vectorized model that I've been sort of mentioning a couple of times. The way it works is that one of the things that it does is that instead of outputting, you might imagine that it's sort of in a naive, simple SQL system, that each operator outputs exactly one row every time you call it. So you're like, give me the next row. So my distinct operator would give me, every time I next it, it's sort of like an iterator, a simple iterator. Every time I next it, it's going to give me a single row. And then the next person is going to either output something or not, depending on, you know, what it's sort of doing. But one of the things that the vectorized model does is that it actually changes everybody to be outputting big batches of rows for various reasons of efficiency. And it turns out that the default and maybe optimal, close to optimal batch size that we've found is 1024. It's a nice round number too, but it seems to also be like a local maximum maybe. And you can imagine that an operator that only outputs like half, like maybe 500 rows at a time, is going to fill up only half of the batch. And that actually causes cascading issues, because every time that you have a smaller batch than 1024 that you're looking at, each operator is going to be a little bit less efficient. In general, it's more efficient to do things in batch, and if your batch size is only 100, then it's going to be a little bit less efficient to work with. And so I think what this selectivity estimate is actually telling us here is not how much of a filterer this operator is, but it's actually just sort of like how much of a batch I'm filling up each time, which is honestly not a great metric, I want to say. So I kind of want to fix this. Maybe this could be a good intro project to doing more in this realm. And so to be totally clear, what we need to do to fix this is, instead of dividing, let's go back to the calculation. Instead of dividing the number of tuples that we output, which is what this is, by the number of batches that we output, what we need to do is divide the number of tuples that we output with the number of tuples that we received as input. And you know, here's another possibility. It's very possible that we decided that this kind of selectivity, in other words, like how much of the batch we fill up, was a useful thing to output. I don't actually remember deciding that, but it's like not entirely out of the question. And if it is useful, then I suppose we don't really want to get rid of it. But I mean, I don't think that it's that useful, to be perfectly honest. I'm kind of curious, like, when did we add this? We kind of added it all at once. And the commit message says, you probably can't read this because it's a little tiny. Add collection of execution statistics for the engine by wrapping each operator with a stats collector. I don't think that we really necessarily were consciously making this choice. But I'm not sure. I'll have to ask the author to find out later. I think in the meantime, though, I'm just going to change this, and we can always revert it or add a new metric for it. And then I think that will be kind of a good change overall. I do really want to see, like, I think it's a useful thing as a person who's understanding how did the query perform, to see, you know, how selective was my filter? How many tuples did I really filter out from my input? So, all right, so how are we going to actually do that? I think the key thing here is that in order to figure out this question, you know, we need to essentially say, like, divide the number of tuples by the number of, it's sort of like, it would be like num input tuples or something like that. But of course we don't have that information here because these stats collectors really only know about themselves. So the question is, can we somehow manage to get the stats of our input? I know we do that somewhere else because we track, so the way that we do this timing is kind of a pain. So if you think about, let's try to imagine just for a second that you're trying to time just how much time was spent doing work as part of this distinct operator. And remember that like the way that we invoke these things is still this sort of general iterator model. We do it in batch, but it's still an iterator. And what that means is that when I am asked for batches, when you call me by saying distinct.next, I'm going to give you a batch, but I also have to do a bunch of work to get nexts from my parents, or my children, my inputs, my parents, whatever you want to call it. So I have to say, in this case, noop.next to get me the results of this noop processor. And if I were to just naively time how long it took for me to run next in completion, I would be including the time that my noop operator took, as well as the time that like everybody above it took. And so that's going to be really confusing. And you're just going to get a graph that has increasing execution time from the top to the bottom, which is not, I don't know, it's just not that helpful. It sort of forces your users to subtract times. They'll see a time here and they'll have to subtract the time here in order to get like sort of a meaningful timing. So we don't really like that. And so the way that we make this all work together is that we hook up these sort of timers together and ask them to like stop each other in a way that I don't really understand. Maybe we can actually figure out the way that works, and that will be a hint for how we can hook up these sort of
computers hooked into
tuple
over
estimates
1,000
together
data banks
in the way that
throughout the
we've been
world.
talking about. Yo, Katsu, thank you so much for the follow. So to do that, we're going to go back to the vectorized stats collector, which is the thing that's really doing the work here. And notice that we have these two kind of stopwatches here. I think that's kind of like the core of what's going on for the most part. And let's go ahead and, so let's read the comments first. Also a really good thing to do when you're investigating code, try to read the comments that are there. That's gonna always help you out. Input watch is a single stopwatch that is shared with all the input operators. If the operator doesn't have any inputs like call batch scan, so that's the example that's in our graph here. That's kind of the thing that's actually reading from disk. So it doesn't have any inputs per se. It's really just like doing IO work, more or less. So input watch is a single stopwatch that's shared with all the input operators. If it doesn't have any inputs, it is not shared with anyone. It is used by the wrapped operator to measure its stall or execution time. Okay, an output watch is a stopwatch that is shared with the operator that the wrapped operator is feeding into. It must be started right before returning a batch when nexted. It is used by the output operator. Well, do I totally understand that? Not really. So let's go ahead and take a look at how these things are actually used. So this is so I mentioned we have this iterator interface, right? This is the implementation of that iterator interface for this stats collector. And if the output watch is not nil, it means that we're outputting batches into another batch, which kind of makes sense. So what we do, let's see, what does it mean? As soon as we start execution, we're going to stop the output watch. Why would we do that? I guess it's so I see. So the flow is sort of that, like, as soon as we start execution as the input to somebody, we stop that person's timer so that they subtract out the time that it took for us to do anything, or for us to do all of our work from the time that they are tracking, which I guess kind of makes sense. So we stop our output watch. We start our input watch, which means our input watch. We're measuring stall time. I think this is the case where we don't have any input, so I'm just going to ignore that case. And then we do our work, right? This is the sort of the critical line. This is like, do the work of our input. So it's sort of like, if I'm looking at the perspective of the stats collector for distinct, this call right here, operator.next, is the work of all of the children or inputs to distinct. And then as soon as we're done with that, we resume our outputs timer, which is sort of a way of coordinating, I guess. So the person that's nexting us is going to get their watch started again because it's time for them to resume work. I don't know. It's a little bit convoluted, to be honest, but I think it does sort of make sense. So I guess the question is, like, at this point, all of these watches are hooked up together. So like I can sort of see my input watch is the same as my child's output watch. So I suppose if we have access to where that's being set up, we could conceivably also set up a link so that somebody can watch how many tuples our input had outputted, if that makes sense. So let's go ahead and see where this is all set up. It's happening inside of new vectorized stats collector. And it looks like we just pass in the input watch. And this is our parents, or I keep saying that. It's really our child or input's input watch. So where does that happen? It's in this big constructor, wrap with vectorized stats collector. Right, so in general case, and this is something I want to talk about, we don't always wrap our processors because we think that this has some overhead. And one thing I really want to think about overall in this stream, once we fix this bug, is like, how much overhead really is it to add the stats collector? And if it's only a minimal amount of overhead, how come we're not just doing it all the time? On balance, I would prefer as an operator or a developer on Cockroach SQL to be able to see at a glance all of this information for any query in my system if the database can do it efficiently. So my thinking is like, how inefficient is this? And if it isn't inefficient, can we make it more efficient and make it efficient enough so that we can have it on all the time? That would be the dream. I hope we can get there. All right, so we create our input watch. We pass it to this vectorized stats collector here, and then I see. So at this point, we actually have access to all of the inputs, and we just like sort of use a setter to set their output watch. I guess this makes sense. So I suppose what we could do is use the very same strategy to hook up like a pointer to the stats that, or like some sort of stats object that each of these inputs are writing into. Yo, Ethan Tataliti, welcome to the stream. I'm working on adding performance counters to a database. If you hit !project, there's like a tiny bit of information there. Honestly, there isn't that much information, but it's something. But we're working on a database called CockroachDB, which is a distributed SQL database. We're kind of trying to make it so that these graphs here, I was sort of talking about them and I'll talk about them again, get available for every single query and not just the ones that you ask for, in a sense. All right, so here's my idea. Like what we do here is that we're hooking up just the watches of each of the inputs to these stats collectors. What if we just hooked up the entire stats collector so that not just like each of these stats collectors sort of mirrored the tree structure of the entire query. So like if we look at the tree structure of this query, we know that, you know, distinct has its inputs, no-op has 2 inputs. What if like the stats collectors of no-op, which sort of live here implicitly, you can't see them in the graph, but they do live here right below the no-op. What if they had links to each of their input stats collectors specifically, you know? I feel like that could be a good way to get around this. Because then not only would we have the output watches and the input watches hooked up automatically, but we would also have access to all the other good stuff. And in this particular case, what we care about is the vectorized stats object here. We can sort of reach into this thing. And you know, the truth is that we don't have concurrency on these things. That's part of what the vectorized engine does for the most part, except for maybe this guy. I think that this guy might give us trouble. I can't remember, but at least in the non-vectorized engine, so like the sort of simpler row at a time engine, this object here, which is an unordered synchronizer, it actually introduces concurrency in its input, so that like essentially this table reader is going to be running fully in parallel with this whole subtree. And I can't remember if we do that as well in the vectorized engine, but that would give us a little bit of trouble. We could introduce some concurrency or some locks, I guess, or synchronization on these things to avoid it, which maybe we ought to do anyway. But let's actually take a look for a second. So if I go to unordered, parallel unordered synchronizer and serial unordered synchronizer, so it looks like we have two options. When do we use parallel unordered synchronizer? It's depending on an option. Fuse option. So it's either fuse normally or fuse aggressively? Man, I have no clue when these things are used, to be perfectly honest. But it seems exciting. I like that we have the word aggressively in this code base. That's like pretty fun. So it does look like we sometimes use this. I don't know. So that's a little bit unfortunate. We'll have to introduce some level of locking to make this all work. But overall, I think I like this idea because there's really no need to just like limit what we're sharing to be these watches. Okay, so let's make it happen. We've been talking for quite a long time. Let us actually make this happen. What we're gonna do is change this set output watch thing to just be something like, it'll be sort of like set children or something like that. Hold on, wait, let's look at where this is called one more time to make sure that we understand. It's saying for each of the inputs, I'm setting my output to something. So what this is saying is really that we want to make, like, what's the word for that? It's sort of like set output stats collector, or like what's the like family relationship word for the way that the secret stats collector here views the secret stats collector here? I think in that case it would be child, right? You guys, I'm like literally the worst at remembering the orders of these things, specifically because this thing does it backwards and I always get confused. So let's see again. In this case, I'm saying like, what would the stats collector of distinct here view the stats collector of the aggregator? And the answer is that it would be called its parent. Okay, cool. So we're gonna say set parent stats collectors. And this is gonna take in a slice of other vectorized stats collectors, a slice of pointers specifically.
Databanks.
Yo, Kubisus, thank you for the follow. And we're gonna say, we'll make a new member variable inside of here called parent. And it's a little funky that we're doing the tree like in opposite order, to be honest. Like maybe we should reorder things so that it's people know about their children and not their parents, but I don't know. I don't know if it really matters, honestly. Since we already, the main tree is sort of set up somewhere else. So this is gonna be the parent stats collectors are gonna be a slice of pointers to vectorized stats collector. Welcome, Sandriel. You can hit exclamation point keyboard if you like the look of this thing to find out more. So I think this is just literally going to be like a setter. So I'm going to say set my parent stats collectors member to be parent stats collectors, like so. Let's change the doc string on this too. So set parent stats collectors. You'd spend 1 year getting used to it and your boss would smack you. I hope your boss doesn't smack you on the regular. That's kind of inappropriate. So I'll set parent stats collectors sets the I mean, it's literally just like sets the parent stats collectors for this operator. I'll give it an example because that's going to make things clear next time I come back and read this comment, because I'm going to be inevitably confused. For example, if you call, let's see, for example, an operator with two inputs, calling this method with a slice of stats collectors for the inputs of an operator with 2 inputs will set, oh my God, this is just like so confusing to explain this. Okay, let's think of a better example here. So let's say, for example, consider the following tree. I'll just draw out a tree and make it really obvious. I think that'll be, we'll say, so we'll have a table reader here. We'll have a table reader here. We'll have a stats collector 1 here. We'll have a stats collector 2 here. And then we're gonna have like, you know, a synchronization point in a sense. Like so. This is gonna be like the world's giantest tree diagram unless I'm careful, so I'm just gonna cut it off now. And I'm gonna have like a, I don't know, I'll just put like a join, you know, join operator, something like that. Not too specific, but whatever. And then I'll have stats collector 3. The intended use of this method is to call set parent stats collectors let's see, just realizing I think I forgot to turn on my stream labels, so the little last follow thing isn't updating. Let me fix that. Hopefully that'll, there we go. Cool. So the intended use of this method is to call set parent stat collectors on stats collector 3 with a slice of pointers pointing at stats collector 1 and stats collector 2. Okay, set parent stats collectors sets the parent sets the stats collectors of the parents of this operator, basically. Whatever. I'm not going to spend too long on this. I've already spent too long wordsmithing this and I'm failing. Okay, cool. So now when we call set output watch, instead of doing it the way that we're doing it, what we're going to do is we're going to assemble a slice of the, you know, input stats collectors is equal to make slice of
data banks.
Vectorized stats collectors, and then it's going to be the length of inputs. Yo, Harry Peter, thank you for the follow. And then we'll say for each of the inputs, we are going to say input stats collectors of I is equal to input. Get rid of this thing. Or we'll go like this, I guess. And then finally, we're going to say VSC dot. Wait a minute. No, I'm totally doing it backwards. Okay, despite like talking about this for like literally 10 minutes, I still have it all backwards. But it's good that we have this example because we can fix it. The intent of this use method is actually to call set parent collectors on stat collectors 1 and stats collector 2 with a slice of pointers containing stats collector 3. Would I get the current 16-inch MacBook or wait for? I would get the current laptop, man. I don't know. Like, I don't think that Apple really has the best track record with the first edition of new hardware. I could be wrong about it, but like I kind of have the feeling that, like, you know, I don't know if you remember when they switched to Intel, but I feel like those first laptops weren't that great. It's the same with like upgrading to a new OS. Like the first edition of OS 10 was like kind of crappy. I would definitely wait. Yeah, exactly. I agree with what Brohanster says. Yeah. Okay, so we have this all set up, right? And then let's just switch the way that we were doing things. So we're going to say input dot, or we'll say sc dot set parent stat collectors to be make. Do we only ever have a single parent stats collector? I feel like the answer is yes, because there's never a situation in which a single output goes to multiple operators. So really we need to change this whole thing to just be set parent stat collector. And we don't even need to pass a slice. So we'll just say, and we can change this to be singular, singular. Okay, cool. Yo, it's Jay Phils, what's up? How's it going? Welcome to the stream. Hope you are doing well, my friend. So we're gonna say set parent stat collector to just be the current vectorized stats collector that we're making. And I think that's all there is to it. Okay, I really overcomplicated that, you guys, but we had to start somewhere, right? It's gone pretty good. It's going pretty good. I think we're getting a little sidetracked on fixing a bug, but I think that fixing a little bug is a great way to break into a new area of the code that you haven't looked at for a while. So I think that's good advice in general. You know, start with little bugs if you don't have a full understanding of what you're doing in a code base. Just gotta start somewhere. Okay. All right, so we've got that set up, right? The next thing I think what we really want to do is probably like delete this method here and replace it with calls to the other one, just to make sure that we're like, I don't know, not accidentally. We also really want to delete this field. Parent stats collector is a pointer to the stats collector of the parent operator of this one. We really want to just delete this method because we don't want anybody to be calling it anymore. Let's actually search for usages first and just like convert them all. So they're both in tests. Merge join input watch. So I guess what's happening here is we really need to move. So look, we set up this stopwatch and we set the output stopwatch of each of the inputs to be this watch. And so what we want to do is, instead of setting the output watch, which we don't really need to do anymore, we actually want to set the whole vectorized stats collector of that input. So I think all I need to do is move this whole thing up above, basically next to where we define this input.
Computers
watch.
hooked into over 1,000 data banks throughout the world.
Alvin Kuruvilla, thank you for the follow. There's one slight problem which is that we can't define this thing yet, but ooh, do we have like kind of a fun like initialization problem here? Like I need to move this thing above to the top now. But then I need to move the whole definition of the merge joiner up top as well. Is that gonna get messed up or are we gonna be okay? I think it's a little bit messed up, you guys. I might have like a bit of an issue here. This thing needs, it's kind of like we did it topologically in the wrong order, but I think it's still possible to get it right because of the way that we have this sort of set output watch thing happening at the very end. I do think that if we just do it in a different order, all will be well, but we'll find out. Yeah. Okay, so that's all good. And then all we need to do now is, instead of saying set output watch, we just need to say set whatever parent stats collector to be the MJ stats collector. Okay. Okay, all good. All good. We can delete this method. And then all we've got to do is make sure, it's like find all the places that we were using that old field, the output watch, and remove them. Output watch. So the way that it's gonna have to work is that instead of checking
Computers
for
hooked into over 1,000 data
just the
banks
output
throughout
watch
the world.
on the stats collector object, yo, Squintev, thanks for the follow. We're gonna actually have to check for the whole parent stats collector being
Computers hooked
not.
into over 1,000 data banks throughout the world.
Sandriel, thank you for the follow. So we're gonna say if this is not nil, we'll say vsc dot parent stats collector dot
The computer's hooked into over 1,000 data banks throughout the
Input
world.
watch dot stop. Yo, thank you guys all so much for the follows. I really, really appreciate it. OX29A, you too. Right. So we were setting the output watch before, and now what we're going to be doing is setting the input watch of the parent. I think that's basically right, but it's definitely at least a little bit confusing. We might want to rename this just to be watch after we're done with this, because otherwise we're going to get hopelessly lost every time we look at this. And then for down here, it's the same thing. If the parent stats collector is not equal to nil, we're going to say vsc dot parent stats collector dot input watch dot start. All right. Okay, so that was a little bit painful, but now we can actually get to fixing this bug, which is what we wanted to do the whole time with the selectivity. So what we're going to do is we're going to go back to where we calculate the selectivity, which was here. Okay, it's not quite enough. It's not quite enough because this vectorized stats thing still is just that protobuf that doesn't have the information about its parent. Like what we really need to do is call this thing on the stats collector, or alternatively, we could plumb in that information into this stats proto as another option. I'm not sure what's the best approach. So like when we call this, what do we have? What are we calling it? We're actually calling it on proto objects that could be coming from the network. So that's like a little bit, That's making me think that what we really actually need to do is add the input stats into this proto, which I don't know. I mean, is that bad? I don't think it is. I think we should just do that. So what we'll do then is add another field here. I mean, it's making me wonder whether I need to do that big refactor at all at this point, because if we're going to just calculate it inside of that proto. But hold on, where did this happen again?
Data banks, data banks, data banks.
Ali Hashmi, thank you for the follow. So for example, no, I think we still need this information, honestly, because realistically, we only have what our input gives us. We don't know how much its input gave to us without having this link. So it's definitely important, that transformation that we did. The question is just whether like we need to fetch that information eagerly, like right now, in a sense. It's sort of like what I'm imagining is that if the length is not equal to 0, besides just incrementing our own batches, what we'll do is we'll reach into our input. So we'll say vsc.parent_stats_collector.num tuples, right? We have this information now. I almost think that that's what we need to do. So let's try that out. We're going to add a new field into our. I mean, I don't love that it's duplicated, right? Like we're already storing this information for the parent, and now we're going to store it again in the child. I don't love that, but realistically, like I don't know. I think it's fine. I don't know. I'm mixed on it. So what we'll do is we'll add a new field down to the bottom here. We'll say, I guess we'll call it num input tuples equals 8, and then num input. We don't even need to count the batches, right? I don't think that that's important. We'll just count the input tuples. So num input tuples is the number of tuples that the input to the operator that this stats collector is wrapping.
Data banks, data banks, data banks.
Yo, letters from the multiverse. Thank you for the follow. I really like that name, by the way. That's cool. Okay. So we're going to have to regenerate our protobufs as well. So let's just quickly do that. I think that the make protobuf is what's warranted here. This is going to take a half second. So
Database.
all right. Yo, Silas Ken, thanks for the follow. So if I go back to my stats.go now, or my stats.pb.go, which is the generated code, check it out. Since we did add that protobuf field, we get an analogous field added to our Go struct. It's kind of the way proto works, right? We define fields in an abstract representation, and then they get, compiled or generated into a actual code struct in Go or C++ or Java or whatever it is that you're working with. So cool. So now we can actually go ahead and manipulate this field as well in our code. So what we'll do is in our stats.go file, we're just going to say vsc.num input tuples plus equals vsc.parent_stats_collector.num tuples. I think this is basically what we want, right? And I think in this case, really, this should be called child stats collector, right? Did I get it backwards? Let's go back to our... This is like, I think that I might be like tree direction dyslexic because I get this wrong constantly. Where is this happening? It's in, we called it set parent stats collector. So what did we wrote that the intended use of this method is to call set parent on number 1. And stats collector 2. No, okay, wait a minute. So this is right, and then what's wrong is actually what I'm doing in this code. So what I actually have access to here, yeah, it's like the wrong direction. That's like slightly troublesome, to be honest. So let's just go over what that means. In our stats.go, where is it? Not stats.go. So what I would be saying here is definitely wrong. It's saying like, I'm saying that I'm adding to the number of input tuples the number of tuples that the operator that I outputted to emitted, which like doesn't make any sense. Which makes me think that maybe we really do need the ordinary tree direction for this stuff. Or we'll just make a doubly linked list, essentially. We'll have the tree know about its parents and children. I don't think that that's that bad. Let's just make that happen. How about? So it does, okay, so here's actually one thing that's confusing, right? Is like, in the case where we had an operator like a join that takes more than one input, what does it mean to have selectivity on that pattern? So like, for example, what does it mean? Well, we don't have a join here. Let's actually quickly make a join to make this a little bit more comprehensible. So we'll start up the database again. We'll go back again to our sample query. Let's just add an object, like some little basic join to see what it might look like on the explain analyze chart. So we'll say, we'll do a count star from this whole thing, select distinct, and then why don't we just join it again with itself just for fun. So we'll say after the select distinct, we'll say select distinct v from join select v from, we'll say inner join select v from kv on v equals v. Whoops, that doesn't make any sense. Wow, I'm like slightly not writing SQL syntax that makes any sense right now. So we'll say inner join kv on, I think I might need to specify an alias for this as well. I guess I don't. Okay. Right, so I've got a hash joiner in here now. So now if I run explain analyze on this thing, I'm gonna get a slightly fancier chart. Ooh, this is also gonna take forever, right? Because I've asked it to do a complicated join on hundreds of thousands of things. So that's fun. Yo, Alex Boss 99, thanks for the follow. This query might take a long time to run. I'm gonna cancel it. Yo, Dr. Beardsley, thanks for the, thank you for that. I appreciate it. Yeah, if you guys didn't see, I did write a pretty cool post on the way that this stream is set up. I should make a little comment for that. It's in my bio. You should check it out though. If you're interested in writing your own or making your own Twitch stream about programming, which if you've had any interest in doing that, you know, I highly recommend that you do it. I have a lot of fun doing this, and I think you can have a lot of fun too. Check out that post. It's a pretty good tutorial, I think. Or at least it's sort of like a good, it's sort of a complete set of things that I did to make this stream happen. If that helps you, then good. So we'll do a simpler join, because I guess this is taking forever. So we'll do explain, analyze, select star from KV, join KV on V equals V. I have to say use, I'm in the wrong database. KV as KV1, join KV as KV2, how about? All right. Learn to SQL. Even this is fairly slow. You know, to be honest, like I sort of feel like the optimizer should notice a situation like this and be able to deal with it, because you don't actually have to do a full join if you're joining two relations that are known to be identical. Like it should just sort of be able to clone the rows or something like that. But I guess nobody really does this. It's sort of like a trivial case. So no point in optimizing a trivial case, right? Wow, Chrome is like totally frozen on me right now for some reason. Come on, little buddy. Why are you so frozen? Mystery frozen Chrome browser? Do I need to restart Chrome, you guys? Oh man. My Chrome instances is like so unhappy, and I also can't see chat. So if you guys are like complaining that everything's busted, I'm very sorry. I'm just gonna quit out of Chrome altogether and see if that helps. All right, hopefully when I open this, it's not gonna like reopen 10 gajillion pages, which would be sort of sad. All right. Okay, so here's the picture I wanted to show you. And let me quickly reopen chat because I can't even see what anybody's saying, if they are saying anything. This is like a first, having Chrome crash on stream. Haven't seen that happen yet. Okay, get that creator dashboard back. Okay, there we go. You know what's also funny about Twitch is that like I can't see if anybody chatted in the meantime. Like I don't really know what might have happened. So rip to that. Anyway, we back. Exactly. Kappa. Okay, cool. So here's what I wanted to show you, right? We've got two table readers. They each are outputting 97 batches. They've got some selectivity, whatever. And then we have this hash joiner that is taking both of these inputs. And what I guess I was asking is like, if this table reader outputted 98,000 batches and this table reader outputted 98,000 tuples rather, what should we say when we ask the question of how many, like the ratio of tuples in to tuples out here? You know, in this particular case, it's actually kind of funny. We have a greater than 1.0 selectivity in this case, because since the way that, you know, we're sort of doing this like cross join thing where for every row we're adding all of the rows from the other side of the table or something like that, or all of the equivalent rows from the other side of the table, since we do have a lot of duplicates. So we're actually adding more tuples in or out than we got in. And like, do we want to report that as like a greater than 1 selectivity? I'm not exactly sure. I almost don't know if it makes sense for an operator like hashjoiner to have a selectivity. It's like sort of unclear to me. You know, it's almost like maybe we only want operators that filter to have selectivity, and operators that potentially add more data.
Data banks.
Shouldn't have that? I don't know. Yo, Spooky Coder, thank you so much for the follow. I guess for now I'll just like make it like a simple ratio, which is going to make this have a greater than 0 selectivity. I think that that's still sort of useful. And maybe we can just sum up the tuples from both sides, something like that. It seems strange for operators that can generate more data to have a selectivity just by the definition. Yeah, I agree. I don't really know what to make of this, honestly. I don't really know. But back to the code, like what we really wanted to do was also set the child so we can traverse the tree in both directions, which I guess is important. So what we're gonna do is we'll make a slice again. Maybe we just want the ratio of input rows to output rows. Yeah, I mean, that's basically like, that's the way I think of it as selectivity. Maybe that's like not really the actual definition. I'm not sure. Yo, Hardlane Bakra, thanks for the follow there. Amplification factor. But like, what's different about that versus selectivity? Like the way I think of selectivity is how, how powerful was the filter? And you can have a filter that's less than, you can have a filter that's completely unpowerful, which is like an example of this cross join thing, right? Like, I don't know. Just whether it's bigger than 1, yeah. I think we should let's just stick with this definition and like, I don't know, see where it takes us basically. So we're gonna say input stats collectors is equal to make, we'll go back to this original approach that we had. So we'll make a slice of pointer to callexec.vectorized stats collector and have it the length of inputs. And then we're gonna set inside of here the ith input stats collector to be this SC thing. And then down at the bottom, we're gonna say VSC.set child stats collectors to input stats collectors. And this is not a method that exists yet, but we'll just make it real quick. And we're just gonna do the same thing here. We'll have a child stats collectors slice, and we'll just assign it like so, vsc.child stats collectors equals collectors. Alrighty, okily dokily. So now we can finally do what we wanted to calculate this quote unquote selectivity. I don't know what we really want to be calling that thing, but who really cares? What we're gonna do is in this operator, every time we finish getting work from our wrapped operator, we're gonna iterate over its inputs and collect the number of tuples that they just outputted. You got a dip. All right, thanks for hanging out, Brohanser. See you next time. Yeah, it's exciting. Thank you all watchers for watching. Cool. Yeah, by the way, I don't know if you guys, all people who are watching, if you're watching and you don't have a Twitch account, you should get a Twitch account and follow me on Twitch, because you'll get notifications next time I go live. And that'll be fun for all of us. I'm literally sitting here begging for likes and subscribes, just like a YouTube person. But hey, you got to do what you got to do, right? Anyway, okay, so here's another slight complication though, which is that when let's say just we did the obvious thing and we iterated over our input stats collectors like this. For I in range, esc.input don't forget to beg for Twitch Prime subscriptions. I don't know if I don't know if I'm there yet, you know. If I were there, what I would say is, did you know that with every I can't even do it. I don't have my pattern down. With every Twitch account that's linked to an Amazon account, you get a free subscription every month. You can subscribe to your favorite streamer. Show your support. That's super cringe though. Super cringe. I don't need to say that. All right. So what I'm going to do is ask for the ith stats collector's number of output tuples and sum them up. But let's say I just did this naively, right? So I said something like num output tuples from parents. And I said something like num output tuple from parents plus equals the, what's wrong with this though? Oh, and this is an int64. All right, so if I were to just add up the number of tuples that all of my children or my inputs have historically given to me, then I'm going to be drastically overcounting because this thing, it's getting updated. It's like a running sum. It's not like a most recent number of output. So I guess what we would need to do is subtract this number from the number that we've calculated so far so that we can have sort of an incremental update or something like that. Or I guess we could just set it every time. That's another option. So what we could basically do is say vsc.num input tuples is equal to num output tuples from parent. And that way we don't actually have to continually like, modify our own num input tuples by adding. We can just constantly be setting it to the sum total. This would work. So if we do this, I think the only thing to do next would be that when we calculate selectivity, which is done over here in stats.go, instead of dividing num tuples by this thing, we're going to divide num tuples by vs.num input tuples. And I guess we have to float 64 this thing as well. Does this make sense? So if, for example, I outputted 200, I outputted one tuple and I got as input 10 tuples, then I would get 0.1 for my selectivity. Is that right? Or is that the opposite of what's right? I think a selectivity wants to be 1. A selectivity wants to be 0 if it didn't filter anything. Honestly, like, shouldn't the selectivity of this thing be 0? Not 1? Shouldn't really just be measuring, like, was this thing selective or not? And if the answer is that it wasn't selective, it should be 0. I feel like we have it backwards. Well, I'll just fix it. So the answer here is that instead of being, let's see, if I wanted to make it so that 0 meant I didn't change the number of tuples, what would be the formula for that? It'd be sort of like, I think it's just 1 minus this thing, right? Because let's say, for example, I got 100 input tuples and I outputted 100 tuples as well. This number would be 1. And so my selectivity would be 0. If, on the other hand, my number of tuples that I outputted was 0, this was 0, and I had 100 input tuples, then this would be 0 and my selectivity would be 1, meaning that I was very, very selective, completely selective. So selective, in fact, that I outputted nothing. So I think this is right. I guess I'm a little bit concerned that this is going to sometimes return 0. So I guess I'll just say, oh, we already have like a constraint for that. So if we have outputted anything, then we would have, I guess I also need to say, like, if vs.num input tuples is equal to 0, then my selectivity, wouldn't you have negative selectivity in the next step then when you actually output? Oh yeah, that's a good point, actually. That's actually a really good point. So what do I want here? So like the example, I guess, is that like num tuples is equal to, I don't know, 1,000, and then num input tuples is equal to 100. The desired number here is my selectivity would want to be 10. And then for the case where I output 0 tuples, I guess I'll just put this in a comment. Output, input, selectivity. So if I had, this example is, yo, Kadobes, what's up? If I had 1,000 output tuples and 100 input tuples, then my selectivity is supposed to be 10. If I had 0 output tuples and I had 100 input tuples, my selectivity is supposed to be 1. Does this make any sense? Does this make any sense? Or is this like completely whacked out? I think this doesn't make any sense, unfortunately. Because like it's not continuous. If I define it this way, like 100 output tuples and 100 input tuples, I wanted this to be 0. And 0 output and 100 input, I want it to be 1. So then, like yeah, it's counterintuitive. I agree. Maybe we need to just not call it selectivity anymore, and then instead call it like, I mean, really, we just want the ratio, right? It's just like the ratio of input to output or something like that. Amplification factor. I'll just like get rid of this 1 minus thing. We'll keep it like the meaning that it is, and we'll try to find a better name for this later. So in this case, if I had 0 input tuples, we always want it to be the case that the selectivity is... it's very hard to figure out what this is supposed to be because of the way that these definitions are backwards. I don't know. Let's just like rename selectivity right now so I can stop being confused. I guess we could just call it amp factor. I do sort of like that. So if I have 0 inputs, then no matter what, my amplification factor is it's like sort of either infinity or 0 depending. So I'll just keep it as 0. Otherwise, if we do have more than one, I guess we could just say this differently. We could say if vs.numBatches is greater than 0 and vs.num input tuples is greater than 0, then we set our amplification factor to the number of tuples that we got versus, divided by the number of input tuples. Okay. Then ideally we could also change the word this word selectivity to be amplification factor. We call this selectivity. I'm not going to change. Well, should I change this right now? Amplification. I don't know. I feel like this needs to be bike shedded by somebody who isn't just me. I'll just do this for now, and we can always come back to it later. All right, so anyway, that took forever, but let's just go ahead and see what happens when we try it out then. So we'll recompile the database, which is what? Okay, invalid operation, can't divide floats by N64s. That's fine. We just didn't cast this thing to a float 64. Doesn't amplification factor kind of imply that amplification is the default instead of dampening, or so when the filter removes elements instead of adding? Naming things is hard. Yeah, I agree that it's not great. Like, yeah. I don't know. I'm also slightly confused. It looks like we calculate this thing twice. We calculated in this method called stats, as well as this method stats for query plan. Why are there two methods for this? One is a slice of strings and one is a map. It seems like we could really combine these things together, honestly. They seem to be exactly the same. Oh, there's a couple of differences. Well, we could probably factor like this part out or something, but maybe it's just not worth it. I guess I didn't. Seems like somebody else decided that it wasn't worth it already. So I'll just go back and fix this other one as well. I think the only change that we did was like add this other condition. If vs dot num input tuples is greater than 0 and this thing is greater than 0, then we do something. And then we call this amp factor. Yeah, I agree. It's not the greatest name. It's truly not the greatest name. I don't understand why we have these things like defined twice at all. Amp, factor, tag, suffix. We called it amplification. I don't know. We can come back to this. We'll revisit it. No problem. No problem. Let's recompile again. Luckily, it looks like we've mostly compiled most of the database recently, so we won't have to do a huge amount of extra stuff. Recompiling C dependencies is usually pretty slow. But this is a perennial problem on the stream, which is that like linking this database takes forever because it's like, you know, the binary is like hundreds of megabytes. And when OBS is running, linking is even slower. Pretty irritating. This is probably, yeah, another reason why I usually like to like test this stuff without having to recompile everything first, but I got excited. All right, so if I run this explain analyze again, yeah, this is like typical. So I made a bug and we got an error back. should have written a test, huh? Should have written a test. All right, so let's just go ahead and take a look at what went wrong. So stats.go 127 had some kind of nil pointer thing. Wait, what line was it? 127? This one. What about filter factor? Factor greater than 1. I like that a lot. Filter factor. That's like kind of a simple thing. I like that. It's a good call. I might use that, in fact. So what happened here? Oh, right. So what we needed to do here is also check. Only do this if the parent stats collector was non-nil. So we'll say if VSC dot parent stats collector is not equal to nil. Oh, and we also, this is also wrong, right? We needed to not use that. Are there any situations where we don't have children? I think the answer is definitely yes, right? That would be the case when we are the table readers, in a sense, like kind of the scan operators don't have any children. What theme is this? It's the Gruvbox theme. You can hit exclamation point theme for details about it. All right, so I think if I just say if vsc.child stats collectors, I guess I could just say if len. Actually, I don't think I need to do this, right? Because this is a slice, and the slice can have 0 length, and the range just won't do anything. All right, let's try that again. Yeah, no problem. I like this theme. It's pretty nice. I used to use the solarized theme, but I got tired of it, and this one I like too. It's easy to spend a lot of time thinking about themes. I recommend that you don't do it.
Computer's hooked into over 1,000 data banks throughout the world.
Hey, Alex and Chavez, thank you so much for the follow. Trying to think, like, where is another place where we test this? I bet we already actually have tests for this that I could just hook into. I think we do have this stats test thing. I don't know quite what it does, but we should probably run it instead of recompiling the database every time. Let's do that next time. If we still have a problem after next time, we're going to run this test and maybe update this test, because presumably this test is actually incorrect now since we've edited the way that the select, or whatever we call it, filter factor selectivity works. Probably we need to update this test. You could spend a day looking for a good theme. Yeah, totally. The lifelong pursuit of the perfect color combinations. Cool. All right, so let's see what happens. Do we get a fail this time? Looks like something's happening. I think last time this query took about 8 seconds, so it still worked, which is great. All right, so we've named it amplification. In this case, the amplification is marked as 0, which like doesn't make any sense. I guess like in the case of table reader, there's no inputs, so there is. I think we should just not output an amplification for something like table reader because it doesn't really do anything in that sense of the word. It creates rows from nothing. So there's no such thing as an amplification ratio really. And in this case, we have a giant amplification factor, which makes sense because we are joining these two things together in a Cartesian product. Okay, and then let's check what the other original query looks like, which is the one that we started by looking at, which I guess is this one. Whoops, but we want to explain analyze that thing.
Computers hooked into over 1,000 data banks throughout the world.
Poisson, my fish, thanks for the follow. So yeah, this is looking more reasonable. Like what we have now is a 1.0 amplification, since we didn't filter out any tuples of our parents for these no operators. And in our distinct operator, we have, this is sort of like truncated, right? Like it's not 0, but it's close to 0 since we do such a giant filter down from 300,000 tuples to 256 tuples. Bailey JE, thank you for the follow as well. And then down here, I mean, I don't know, is this useful? Like we start at 256 and we go down to 1. Like maybe we just need to up the precision of this thing. So it's like maybe have 4 digits instead of 2 or something like that. What package is used to generate these graphs? This is like, I don't know. I think it's like some graph viz thing. This is all like in browser. So I guess if I just look at the sources for this thing, I should be able to find out. Looks like maybe D3. Like I think D3 has a force generated graph thing. I think we're using this. But not positive. I didn't write this code. It's really useful. I didn't write it though. Yeah, I don't know. I mean, I'm mixed. So let's actually figure out, I'm very curious where we do this truncation, actually. Where do we decide to just output 2 digits? Is that before we send to the browser? Or after we send to the browser? Hey, launch all zig. Thanks for the follow. I like that reference. You know where it's at. I thought it was, did it launch every zig? All your base? I can't remember that. Anyway, so let's see. Let's just try to figure out real quick where we do that truncation of float, just for my own edification. If we go look at this selectivity number, where do we even write that down, by the way? Oh, I see. We write it down here. So we look at this tag suffix, then presumably somebody else comes around and... Oh, no, it's right here. Format.2f. Okay, so we can just change this to .4f and see what it looks like. Just because I don't know. I just want to see it. And then, okay, so I guess while this compiles, I want to talk for a second about like my goal for the rest of the stream. I didn't really intend to go down such a long rabbit hole with fixing this number, but I did. I think what I want to do at this point is just change well, let's see, how do I say this? My end goal is that while you're running a workload, I want it to be possible for you to query the database to see how much resources of various kinds are being used, bucketed by query, if that makes sense. So for example, if like my query took 500 milliseconds reading from disk and 250 milliseconds doing other CPU processing. And that 250 milliseconds was further split up into 10 different operators. I ideally would want to be able to see that information at any given time for all of the currently running queries in the system. And in fact, I would sort of want it to be possible to see that information for queries that aren't currently running, right? It's like I want this history to be saved in memory at some resolution in a compressed way so that I can look at it over time to try to analyze stuff. That's like my end goal. I don't think I can get to it today on the stream, but I guess my hope is that we can try to quantify how much resources it takes to even capture this information in the first place, and maybe come up with a way of extracting it via virtual tables. Like we can get this, the only way that we can get this right now is by using this explain analyze thing, where you actually pull open you have to tell the query, please collect these stats, and also you have to pull open this browser window to look at it afterwards. And ideally we wouldn't have to do that. So I don't know. Anyway, so let's just quickly take a look to see what that change we'd made does, if anything. Hopefully we should see a bit, 2 more digits of precision. Okay, so I really just wanted to see this, to know for sure that I didn't screw up the calculation. We are getting, our amplification or our filter factor is just a very small number. Yeah, okay. So if I wanted to try to capture all of this stuff all of the time, I think what I would need to do is try to figure out who's calling these stats for query plan things, or I guess the other version is also sometimes called, and see if I can call it, I guess, basically all the time. Just 2 steps. I need to enable the stats collection all this time, and I need to have somebody besides this graph builder thing ask for these stats all the time. Keeping track of this account, thanks for the follow. So as you can see, the workflow for not the workflow, but the call stack, I guess, of the things that are extracting these stats, it originally hits from something called diagram data, and presumably that is just getting called from these explain methods. I suppose ideally I could just call this thing, or this, I could call extract stats from spans all the time, associate these stats with these processors all the time, and then write them to some kind of system table or something like that, I mean, honestly, the other thing that I would like to just mention is that if I could have a view, let me pull up open that pprof again that I had open. So if I had a view that sort of combined this view with this view, in the sense that sorry, I mean, that's not totally clear, but really what I want is at any time I can say, hey, database, please print me a graph that looks like this, that contains information about all of the queries running right now. So how much time am I spending in any table reader? How much time am I spending in any distinct operator? Is that a useful view? I guess it's sort of hard to know. At what points do you want aggregate data versus at what points you want to have per query data? There is this other thing that happened recently that I thought that maybe it's just my binary's a little bit too old. I think that we added some way of having pprof keep track of, what is this here? Debug, productionize pprof labels, add to debug zip. We take CPU prof files in various places, add a number of helpers. So I think, let's see, I guess I sort of have to pull this into my binary to use it. Do I have this in my current? No, I don't. Let me just quickly check out that branch. It'll be worth it because I think this is actually really cool and it's very relevant to what we're talking about. I guess I'll just, let's see. Well, first of all, we have some changes. So let's like quickly make a branch and change it and stuff like that. So I'll go back to master. I'm gonna check out a new branch. I'm gonna add all these files. Selectivity calculations. So I guess I'll say previously the selectivity of an operator was measured as the fullness of each batch rather than the more obvious and probably more useful metric of how much of a filterer the operator was. This commit changes the calculation to be the more useful version. Honestly, like, to be perfectly honest, now that I think about it, I think we probably want both of these stats because I think like at a certain level, it is interesting to know how full each of the output batches are. Because like I was saying earlier, you know, like if you have an operator that's outputting really empty batches over and over again, that's going to really hurt performance of the things that are next in the pipeline. But that's like more like debugging information than information that customers can really use or like people who are using the database can really use. So to be honest, I'm probably going to go back and just add both of these metrics, but I'll just keep this for now. Okay, so I'm going to rebase this on top of what is currently on top of the remote master because I want to recompile to get that new pprof stuff real quick. So we'll do that. Might take a second, honestly, but hopefully not too long. It was a really great day earlier here. I don't know if you were around last week, we had like a major storm during the stream, which caused like serious internet connectivity issues. And I had to end early, which was kind of a bummer. But, and I was sort of afraid that that was gonna happen again today, but it's gotten a bit sunnier. Normally like this time that I stream on Friday, like if in another hour or two, like the sun will like nicely stream on my desk, highlighting the keyboard. It's a nice moment. It's kind of like the Instagram moment for my keyboard and desk setup. The sort of late afternoon here. I guess that's what you get with a west-facing window or whatever I have. But yeah, no storms. I hope everybody has good plans for this weekend. I'm probably gonna try to go biking. I've been wanting to go biking for a while and I haven't gotten a chance, but my dream is that I could bike a little bit this weekend. It's one activity that feels like pretty safe to do during COVID because you're just constantly getting all this fresh air. I live in New York City, so there's a lot of people around, but if I can find a nice quiet place to bike, it feels pretty good. Okay, so we're coming to the end of the compilation, which is great. Is it raining in New York this weekend? You know, I don't know. Let's find out together. I can drift with the bike. It's looking like, oh man, we got a hot weekend. 93 degrees Fahrenheit tomorrow. That's another thing that, I don't know, people love summer. And I like summer too, but I have to wonder a lot of the time when people love summer, is it just because like they're remembering from their childhood that summer was great because they had no school? I feel like that has a big to do with it. Have I ever heard of a pump track? I've never heard of that. Is that thing where you like go in a little mountain bike up and down or something like that? I have never heard of that, but I've seen videos of people sort of pumping their bikes up and down, and I wonder if that's what you're talking about. Okay, so just out of curiosity, at this point, if I go now and I run my workload, wow, I have like way too many windows open right now. Let's close that one, close that one, close that one. Okay, so if I run my KV workload now, dude, I have so many windows open, it's like extremely disturbing. Okay, I'll just make a new one rather than find the one I was looking for. It's totally legit, right? So if I take a pprof, I'm hoping that my pprof will now include information about each of the queries that are running. Doesn't seem to. Wonder if I have to enable it. Don't have any tags. Let's see. So if I check out my git log again, maybe I can figure out productionized pprof labels. But how do I get this special pprof? Maybe if I go to the web UI, I'll be able to figure it out. Localhost 8080. No? It's because I turned off the database, obviously. Okay, try again. I did in fact build the binary without the web UI. All right. So that was my bad. Let's just try to figure out basically from the source code. How about it? We can check out this commit again and see what they did. Productionize pprof labels. Do I need to pass a special flag? Into this thing. If I search for tags. Huh. Oh yeah, check this out. I need to pass labels equals true. Okay, that kind of explains what's going on here. So if I just run again, turn on my database, turn on my load, and then I pass in and labels equals true while running the workload. Hopefully I will get this tags information. Okay, try again. Web. Okay, I think now I do have some interesting information here, which is that at the bottom of my profiles, turn off that workload. At the bottom of my profiles, each of the nodes in the graph is connected to a tag, and the tag has as information the query that was used to generate the stack that contained the sample, if that made sense. So what this is telling me is that two of the queries that were used to generate the query that caused visit internal to use this amount of CPU or something like that were both of these upserved queries. I don't exactly know why they're not aggregated. Like you can see that one of them was served on port 58981 and one was served from port 58973. It doesn't make that much sense. I sort of think that these should be coalesced together. But this is kind of a cool thing because it attempts to tell you to attribute, you know, what query was causing the load, or what query was causing the samples to be taken, in a sense. I don't know if that makes sense. I guess as another example, what we could do is run the query that we were using before, that join, and we could see what it looks like in the pprof. That could be kind of interesting. Yo, Bantu Caravan, what's up? Welcome to the stream. I hope you're having a great day. We're just hanging out doing some investigations of performance on the database and having a pretty good time doing it together. But if I were to, so if I were to open my SQL shell again.
Data banks.
Yo, Emilio Shepis, thank you so much for the follow. Welcome, Emilio and Bantu. So if I were to run this select, let's do the join, because I think the join was kind of slow. It was like 8 seconds long. If I were to run this and then quickly at the same time take a profile, so let's hit this. Wait, use KV first. I'm gonna hit this. I'm gonna go over here. I'm gonna hit pprof. Then I think what's gonna happen is that this pprof is gonna be sampling what the database is doing while collecting this information. And then this is actually kind of cool because we can compare the output that explain analyze gives us, which is this, to the output that pprof gives us, which is this. So if we look over here, what does it tell us? It tells us that we did, 65 milliseconds reading data here, 65 milliseconds reading data here, and 25 milliseconds doing execution, which seems quite wrong, by the way. I do wonder, I think we might have screwed up when we changed the way that selectivity is estimated. I kind of think that we messed up these timers because this actually doesn't make any sense. This should really say something like, 8 seconds or whatever, however long the query took. Most of the effort here is doing the hash join. That's sort of the expensive operation. But anyway, if you go back to the pprof, what you can see is that for each of these boxes, we can try to see what's expensive. And really, we should be able to prove if, in fact, the hash joiner was the expensive thing. We should be able to prove that. We can kind of prove that because hash joiner exec took a long time. Now I'm wondering, though, maybe a lot of this time was spent just outputting the rows. So if I change this to be a select count star, maybe we'll get a more of an interesting graph here, because I don't want to be just timing how long it takes to serialize the in-memory data to the output. That's kind of boring. So I'm going to change it to be select count star, run this, rerun the pprof, and then we can compare those ones. Okay, so this only took 2 seconds, so that sort of proves that a lot of the effort was spent doing output serialization. Dr. Beardsley says, delayed reply, pump track is a bunch of rollers that you can write it indefinitely without pedaling. Wow, that's actually super sweet. That sounds like a lot of fun. 318 Kent Avenue. I vaguely know where that is. I do want to check that out. That might be a lot of fun. Yo, Bantu, we should do that together. So if I hit web on this guy, so this is kind of a cool looking pprof, right, you guys? It's you see all of these red things. Each of them have 0 on their self time because they're not doing any of the work themselves, I guess. But if we keep following these arrows and we go all the way down to the hash joiner, we do see that this hash joiner stuff is taking up 230 milliseconds of samples or something like that. And then hopefully at the very bottom, we should also see that they're attributed to queries, but I don't actually see that. So I sort of wonder whether that query attribution thing is busted to some extent, or yeah, I don't know. I don't understand those tags. Anyway, it's you can imagine though. You can imagine that if you had a thing that allowed you to see in this graph whether, let's pick a better box. This call to hashjoiner.congregate, that's a big chunk of what the hash joiner has to do its job. You can imagine that if congregate had an arrow to a box saying that 10% of the calls to congregate were for that hash join that I just emitted, and 90% of them were for some other hash join that wasn't the one I was testing, then that would tell you something. And that would be interesting and useful to have as the consumer of a database, right? You can know that much of your time is spent serving query X and almost none of your time was spent on serving query Y. Tim Click says, it's nice that nodes that are taking time and probably where you want to spend your time thinking about are big and bold. Yeah, I like this visualization quite a lot. How it makes the red arrow super fat when it's in this case, 100% of the time in this method exec infra.run is spent just doing calls to materializer.next. And you know, so on and so forth all the way down the chain. It does tell you quite a bit. It's a pretty good visualization, I think. This is not something that we invented, by the way. Like this is a pretty standard output from this program called pprof that I don't exactly know the lineage of pprof, but I know that it probably came from not Go. I think it probably started as a C++ thing, is my guess. And Go just used it. Not totally sure. I bet somebody in the chat would know better, but anyway, another big digression, to be honest. One thing, I need to go back. This is annoying, you guys. I'm really sorry that I went down this rabbit hole about fixing the selectivity, because I'm fairly sure that this execution time now makes no sense. Like, I was expecting to see execution time of hash joiner be more like, I don't know, several seconds, and I do think that I probably broke it. So let's just try to double back and fix that. Let's just think carefully about what we've done here. So parent stats collector is a pointer to the stats collector of the parent operator of this one. And so what it says that what we're doing here is we're stopping the input stopwatch of the parent operator. I am still just super confused. So let's go back to the diagram that we drew earlier here. When we call set parent stats collector, we're saying that we're setting, you know, this join operator to be the parent of stats collector 1, or rather we're setting stats collector 3 to be the parent of stats collector 1 and stats collector 3. Okay, that makes sense. And then the question is, when we actually invoke the stopwatch of this thing, does that make sense? I think it actually does, right? Because what we're saying is that we have this stopwatch here on stats collector 3 that's about like the time that it takes for to process its inputs. So it sort of does make sense that we would want to stop that operator, like stop the operator, the stopwatch of the input of stats collector 3 when we're doing work up here. Because the whole point is we want the stopwatch of stats collector 3 to represent just the time that we're taking to inside of this join operator. I think the thing that's a little bit confusing and possibly wrong is that this join operator has 2 inputs, of course. So wait a minute. Oh man, it's a puzzle. It's a puzzle. So let's imagine we're the hash joiners stats collector. What is the sequence of operations that we want to do? As soon as we get called, don't we want to be stopping the stopwatch of this guy? And not this guy? Don't we? I think the thing that's confusing here is that, like, I need to fill this example out with one more thing, to be honest. I need to fill it out with a single input thing. So like I don't know, like an aggregate or something like this. The aggregate operator would also have, you know, a stats collector 4 or something like that. And this would be, the join operator would be outputting its results into the aggregate. And then I guess the idea is that we would, to call set parent stats collector on number 1 and number 2 with number 3, and to call set parent stats collector on stats collector 3 with stats collector 4. And so then you just looked it up and actually the pump track in Brooklyn has been leveled. That's like the most depressing thing I've ever heard. I did get really excited about that, but oh well. Rip in pieces. Rip in pieces to those ideas. Okay, so let's imagine for a second, right, that we are calling next on stats collector 4. We need to be thinking about this one, right? Not this one when we stop the stopwatch, right? Which means that, like, I don't get this, to be perfectly honest. I'm quite confused. I do think that this is exactly the same as the old code, right? It's like, let's take a look at it. Let's take a look at it. What we used to do, you know what? Actually, just out of curiosity, let's stash this thing and just check out what happened before we made our change, just to see if in fact my suspicion is right and what I did made no sense. Because hopefully, if the change that I did didn't make any sense, then like it's going to be super obvious really fast when the execution time of that middle node is like really high. But if it's also low, then like maybe it's just like it doesn't actually take that long to run the hash joiner in this case, and all is sort of well. So I just want to compare what we did to what we used to have. And then after that, I promise we can try to actually collect stats and everything, which is the dream. By the way, Dr. Beardsley, I have been making like a decent amount of progress on playing Quickie World 2. I've made it to World 3 of Quickie World 2, which is, it's been taking forever. And I'm currently demotivated again on this level that I don't know how to beat, but I'm making progress. I think that if I can ever beat it end to end, I'm gonna try to do a stream where I rebeat it end to end in one sitting. I don't know, it might take like 12 hours or something, but I'm gonna try it. Okay, so let's run this explain analyze again and see what we get this time around. Yeah, you know, we still get 15 milliseconds, which honestly just feels wrong to me. It really feels wrong to me, and I'm very suspicious, I have to say. I'm very, very suspicious. I feel like this code just isn't really working the way that we thought it was gonna work. And so I think we can fix it though. That's fine. This is actually making me feel happy because I think I'm starting to understand what's going on. So if I go back to my, selectivity fix branch here, what I really want to do, what I really want to be doing is just from first principles, right? Like, what is the sequence of operations that we want to do with these stopwatches? What we want to do is we want to stop the stopwatch of the operators we're outputting to. I'm stuck on the, I think it's the first level of the third world, the one where you're supposed to like use a little bomb over and over again to knock down obstacles without the bomb blowing up. And you have to, the thing that I'm stuck on is where you have to like slide down a slope with this bomb to get momentum, but I can't figure out how to slide down the slope to get momentum while also holding the bomb. I think you have to like let go of it and slide and then recatch it and then jump or something, but it's just like a really hard sequence of inputs that I can't really figure out yet. Total tangent. Super Mario World. ROM hacks. Good sequence. Good thing to talk about, but not programming really. So what we do is we stop the stopwatch of the operators we're outputting to. We run the run the, what do I want to call it? Like run the work from all of our, well, it's specifically actually like run the operator we're wrapping. That's what you have to do, and it's a bit tricky. Yeah, definitely. It's tricky. I need to like watch somebody who can do it, who has like their inputs on screen or something, so I can figure out what they're actually doing. Okay, so we run the operator we're wrapping. Then I guess we restart the stopwatch of the operators that we're outputting to. Yo, Cypher, what's up? It's going pretty good. It's going pretty good. I think we're making like slow but steady progress on this project that we thought we were gonna get to. I think realistically we're doing less on the project that we thought we were gonna be doing and more on fixing a couple of bugs that we're noticing, and I don't know, just understanding this code. I think I was overly ambitious, as I often am, about how much I could get done with this, but what are you gonna do? I'm also chatting with Dr. Beardsley about where I'm stuck on this Kaizo hack at the same time. Speedrun.com is a good place to find videos. Yeah, that's a good call. I should probably do that. I've watched some videos, but I don't know what their inputs are. Overly ambitious is the normal state of development. Yeah, exactly. Right. So, and if we do this sequence of operations, right, if we stop the stopwatch of the operators we're outputting to, and then we expect that when we're done, we restart the stopwatch, then hopefully those operators themselves will get their stopwatches timed just for the components that they were actually working on. It's really so brain bending, I find, but I don't know. I almost think that it would have been better to just have every operator have a full stopwatch and just subtract the time that was taken in the inputs, in a sense, from their own stopwatch. But even doing that's hard, because you always have to have like this implicit tree between all of the stats collectors, no matter what. And that's the hard part. It's not really like the subtraction or the multiplication or whatever little math you're doing. It's just like keeping track of this tree that it's a big pain. So, I mean, to be honest though, like this does make sense then, right? It's like what we call parent in this context is the thing that we're outputting to. The things that we're asking for stuff from is our children. And so I don't really get why this wouldn't work then. Because at the bottom, what we do is we restart our input watch, our parent's input watch. You know, maybe what would help, like, I guess we could just like log a couple of bits of information or something like that. It's like, can we describe the structure of wrapping versus outputting to? Yeah, absolutely. Okay, so I'm going to show you this diagram, which is sort of the diagram that we're looking at, trying to understand all of this stuff. So essentially, all of the objects that we're talking about here are components in a SQL plan. So this graph corresponds to this SQL query here. I'm going to pull them both up on screen in a sec. So if you look on the left side of the screen, you can see that we're running a count star from a table, and we're joining that table to itself. It's just sort of a dumb query that doesn't really mean too much. And so the plan for this thing, you can actually, whoops, I guess I turned off the database. So let me turn that on real quick. The plan for this database looks like this. On the left, again, in text, we're seeing two scans. We're seeing a join between the rows that come out of those two scans. We're doing a render, which doesn't really matter. And then this is where we do the count star at the top, a group by. And this graph up here is an alternate view of this exact same information that includes these statistics. That's the thing that we're kind of trying to keep track of. And so what do I mean by wrapping versus outputting to, or whatever? What does that all mean? What it means is that when we're collecting these stats using this explain analyze variant that I'm sort of working on, we plan a secret little operator here at the sort of at the bottom of this table reader here. And by the way, this table reader thing corresponds to this scan thing. It's just another word for the same thing. So you can imagine in this graph, what this would look like is instead of having these scans output directly, or I guess I'm using this output word implicitly, but instead of having these scan nodes directly connect to the hash join, they're going to have individual like stats collectors living right above them. So the scan is going to be connected to a stats collector. This scan is going to be connected to another stats collector. And then those two stats collectors are going to be connected to the hash joiner. So the hash joiner won't see any scans directly. It's going to be going sort of through these stats collectors. And so when I say outputting to, I really mean that like the rows that are coming out of this scan are like flowing through this line, you can imagine, into this hash join. And same for this scan. The rows from this scan are flowing into this hash join. The result of this hash join is flowing through this line into the render. The result of this render is flowing through this line to the group by. And in this graph, it's just sort of the opposite direction, you know, top to bottom instead of bottom to top. Each of these nodes is pushing rows down this arrow into the hash joiner. Each of the hash joiner is pushing rows downward to the aggregator and so on. And so when I say wrapping, what I really mean is just that little operator that we're sticking here in between each operator and the thing that's asking for rows below it, in a sense, in this diagram. I don't know if that makes sense. It's a little bit brain bending, unfortunately, which is why it's a bit of a struggle to make any of it work. So yeah. You know, this is actually a perfect situation in which I really want to have my iPad, because I would be able to draw this dilemma that I have with the timing. But the iPad's in another room. So if you just hold on for 1 second, I'm just going to be right back, grab that iPad, and just give me a second. Okay, I'm back, and what I really want to do is just quickly hook this thing up so I can show you guys what I'm talking about. So let's see, if I plug it in like so, open up this drawing app, and then hopefully over here, it will eventually make itself visible. Currently is not making itself very visible. Oh, there we go. Okay, cool. It just takes a little bit to like sync up. Okay, so here's the problem. The problem is that let's say we had our hash joiner down here. And since now I can draw, like I'm going to show you what I'm talking about with this like wrapping versus outputting or whatever. What I actually have is another box down below, which is the stats collector for hash joiner, stats collector. And what happens now is like essentially instead of like asking for rows from the hash joiner, which is what we would ordinarily do, like give me rows. That's sort of a stupid thing to say. I'm not going to write give me rows. The way that we ask for rows from an operator in this database is we kind of call its .next method, and that's going to like tell the hash joiner to like do its work, to do its hash joining. And the dilemma comes in when we're trying to figure out how much CPU time is spent inside of the hash joiner. And what the stats collector does is it starts a timer. So it's essentially going to say, like, I'll draw in blue, start timer. Start timer. It calls next, and then it says stop timer. Now, the problem comes with the fact that the hash joiner itself also has inputs, right? And in this case, there's these two table readers up here. So I'll put a table reader here. And I'll put a table reader here, table reader. And in order for the hash joiner to do its work, like much of what it has to do is call that very same .next method on the table reader. It's sort of a chain of people .nexting each other. And so if I were to just naively count how much time was taken in .next of hash joiner, it would also include the time taken in these .nexts of the table reader. So the challenge is to somehow figure out a way to subtract out the time taken in these, I guess I should really make, I can like make these sort of orange. And I want to say like, how do I subtract out the time taken in the orange ones from the time taken in the blue ones, if that makes sense. So it's sort of like time of hash joiner dot next minus time of table reader dot next. And so this would all be like pretty straightforward. I feel like if we just could subtract the times, but doing that is also irritating. So what we've done is we've actually made it possible for the table readers, when you call, so the way it works now is like when I call .next on the table reader, I actually like stop the hash joiner timers. That's like part of the work I do as the stats collector for the table reader. So one other element that I haven't quite described is that like below these hash joiners, below these table readers, there's also stats collectors here. So stats collectors are here. It's like this big tree of stats collectors and operators in a sense. And stats collectors here. And essentially like when I call next on the stats collector, I stop the timer that's over here. I don't know if that makes any sense. It gets quite complicated. The table read happened before the hash joiner. Yeah, in a sense, like even though it's sort of above the hash joiner in the tree, it does happen time-wise before the hash join. Yeah, I mean it's all sort of at the same time, right? Because this computation happens in batch. In order for me to get information out of the hash joiner, I only ask for a little bit of information of the hash joiner at a time. And to do that work, I only need to ask, like the hash joiner only needs to ask for a little bit of information at a time from the table reader. So it's sort of incremental, it's sort of streaming, which complicates all of this stuff quite a bit. If it was just like a full pipeline where, inputs get fully processed before the next thing, it would be a little bit easier to keep track of. But this stuff is all iterative. So it increases the complexity a bit. But Douglas Correa and Exendro Iniant 245, thanks for the follows. Anyway, okay, so coming back though to over here, I think truthfully, this is like super janky with this keyboard thing. That's okay. Truthfully, that's what's going on here, right? So when I call next, this is what I was trying to talk about on the drawing. This next method here is going to stop the stopwatch of the, in this case, it would be stopping the stopwatch of the hash joiner as the table reader stats collector, if that makes sense. And then it does its work. Then it restarts the stopwatch on the hash joiner down here, down here. I mean, I don't know. I feel like this does make sense, but like somehow like it doesn't really seem to be adding up, right? If we go and look at the actual time it takes to run this query, 2 seconds, and we look at the execution times that we're reporting out here in the hash joiner, we only get 20 milliseconds. So like, something is definitely wrong. 100%. Maybe what we could do is like, we could print out just some information about what's going on to try to debug it, sort of a way that we could move forward here. Let's read the documentation on input watch. Input watch is a single stopwatch that's shared with all the input operators. If the operator doesn't have any inputs, it's not, yeah, I mean, this is basically what I was trying to explain. It's shared with the input operators in the sense that, like, my inputs have a pointer to this whole struct, and they can reach in and poke at this input watch. And let's just double check. When we set these things up, we're looping through all of our inputs, and for each of the inputs, we're setting the parent to be the thing that we're creating. I mean, I think this is correct. This is correct. So it's perplexing, honestly. And we could just out of curiosity, I want to see what happens when we log some stuff. It'll be a huge amount of output, but it'll be kind of interesting, and maybe it'll be sort of instructive. We'll see. So we'll say, you know, stopping input or stopping stopwatch for so for parent of operator, and then we can maybe print out some information about who we are, hopefully. So VSC dot, what kind of information do we have here? Yo, bzz, thanks for the follow. I don't speak Russian, unfortunately, so I don't know what to say to you. I'm not sure what you're saying. What kind of information can we print out to identify ourselves here? Maybe we can print out the type of our input or something like that. I think that'll help. PSC dot input. I thought we have it. PSC dot operator, it's called. What code editor? I'm using Golang. So if you hit, actually I have a command for this because people like to ask this all the time. So if I hit exclamation point editor, it's going to tell me some stuff here. I could use translator, yeah, but I'm streaming right now, my friend. I think it's not fair for you to ask me to do that. Okay, so I'll say stopping stopwatch for parent of op blah, and then down here I'm going to say starting stopwatch. Okay, so let's recompile with this and see what it gets us. This is going to be interesting. Maybe we'll learn something. If I don't stop it, do I get the full 8s in all boxes just as a sanity check? That's really smart. Yeah, that's a good point. I'll do that next. Thanks for that suggestion, Chalunde. Why are all programmers on Twitch with such strange keyboards? It's a good question. I think there's like a bias effect going on. It's like the more, like if you have a strange keyboard already, the more likely it is that you're going to want to show it off when you're doing a Twitch stream, just because it's sort of fun, you know? That'd be my guess. I think there's like a selection bias in your method here. Buzz. What's your hypothesis? I do wish it didn't take so long to recompile this thing. It's kind of a pain in the butt. All right, so we'll run again, go over here, we'll run our explain analyze. And, all right, we were supposed to look at the log output, right? So in order to get that, we have to do log to standard error. And hopefully this will just print out a crap ton of information. It's probably gonna be a little bit overwhelming. It is in fact extremely overwhelming. What's kind of interesting to me that it seems to be like we're only starting and stopping a stopwatch for a particular operator, this simple project op thing. So let's try to figure out what is the simple project in this case. I think if I do maybe select. No, how do I get, is it verbose? Okay, so here's the like verbose version of this plan. So what's kind of interesting here is that I would really expect to be getting more calls to this. Oh, maybe it's this simple project op. It's a little hard to say. It's kind of annoying. Your developer to use 10 keyless keyboard. All right. I'm confused. I'm confused. You know what we should do is also, besides just logging this, we should also log the ID of the operator, just so we can kind of understand that. Maybe that'll help. I'm also going to take Chalunde's suggestion and just turn off the stopwatch stopping to make sure that things add up properly. So I'm going to just turn this off altogether. But we'll keep the logs, because the logs should be the same no matter what. Let's see what happens with this. What's going on with my back? I'm just sitting at an angle. Dude, are you trolling me right now? You want me to sit up straight? Here, I'll show you what it looks like to sit up straight perfectly. Perfect posture. Buzz, 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 asking the real questions. No yoga, please. Yeah, it is more healthy. You're probably right. That would be kind of a funny thing to use for my channel points for, like posture check, 1,000 channel points. Okay, so if I run this again now, what do I get with explain analyze? So we still get this information about the thing. It looks like we're always touching just that number 2 operator for the most part. Maybe some 0s and 2s at the bottom. Or some 0s at the bottom. I don't know what the deal is with that. But if I open up the plan now, I get 0 execution time everywhere? That's definitely not what I was expecting. Get out of here. Y'all are trolls. Y'all are absolute levels of trolls. Can't mention Yugabyte on this stream. I untimed you out. Didn't I comment out the start? I did comment out the start, but I thought that technically, each person is also starting their own input watch, you know? Like, in a sense, maybe I sort of still misunderstand how this thing is working. But look, I was kind of expecting that going back to the drawing for a second, like if I am the stats collector for the hash joiner, and I want to time how long it takes me in hash joiner, I was kind of expecting that what I would do is start the stopwatch myself as soon as I get invoked, and then let the inputs of the hash joiner stop and start my stopwatch again as necessary, you know? But it sort of seems like we're not even doing that, which is a little bit confusing. I almost think that that might be the bug. Like, I almost think that we need to have this happening all the time. What is this if we're measuring stall time? Stall indicates whether stall time or execution... Oops, I need to switch back to the desktop. Sorry about that. Stall indicates whether stall time or execution is being tracked. And we set that when is stall... Yeah, we set it when... I feel like this is actually probably the bug. Only the leaves start themselves. Yeah, exactly. Right now, only the leaves start themselves. But that seems wrong to me. You know? That seems quite wrong, honestly. I think that we need to have the... I think we need to have this thing start itself, right? Cool. Thanks a lot for stopping by, Buzz Buzz. Hope to see you next time. So let's just get rid of this and see what happens. Hopefully, if we get rid of this, then we'll get the sort of sanity check output that we were hoping for. Everybody's going to be about, 3 seconds or 8 seconds or whatever it is. And then if we get that working, maybe we can reintroduce the trickiness. And hopefully that will get us to where we want to be. Would be great to speed up the cycle on this guy somehow. I'm suspicious of the unit test though, because we have, what's funny is we have a unit test for this stuff, but I feel like it's got to be wrong because the results of this thing, the actual results are like egregiously wrong, which feels like if we were unit testing something, it's got to be not exactly what we want. So anyway, okay, so let's run this guy again. Go over here, we'll run our explain analyze. It's gonna log way too much crap. I should probably turn that off too. And then hopefully now in our view. Okay, so this is much more good in a sense. Like what we see is the aggregator takes 7 seconds, which means that it took 2 seconds, I guess. The hash joiner took 5 seconds, which means that it took 5 seconds minus 67 plus 113 milliseconds. And so then the only thing that we need to do to fix this is to start and stop those other stopwatches as necessary. So let's try that out. Let's turn off these logs. So I don't think they're really helping us, honestly. So hopefully this will work out. Yo, birds and bears, welcome to the stream. We are working on adding performance statistics that are always on to CockroachDB, which is a SQL database. To be honest, that was our original goal. At this point, we're just trying to debug a problem that I don't understand. It's taken quite a long time, but I think we're learning. I think we're figuring things out along the way, so hopefully that'll be all right. But right now, I'm really just waiting for the database to recompile. So that's step number 1. But basically, what we're hoping to see right now is that in this graph, we're hoping to see that this execution time line includes only the time that it takes to sort of quote unquote run this box here. Instead of this box plus all of its inputs. That's kind of the current sub goal. I think what's really confusing about this metric execution time is that all of these things they're not running sequentially, right? It's like there's time slices. The hash joiner runs a little bit, the table reader runs a little bit, the hash joiner runs a little bit more, you know, back and forth and back and forth. And so that can be very confusing. And partially why we need to improve this stuff, just because it is so confusing. All right, so let's run this again. We'll run our explain analyze, and maybe this time we'll see something happy. Yeah, this is looking good. So we see 3 seconds of execution time on the hash joiner, which is most of the 3.4 seconds we see total. And we see just a few hundred milliseconds as the sum of the actual, you know, reading of the data off of disk. And we see almost no time spent in the aggregator, which is basically what I would expect. The aggregator, all it's doing here is just counting its inputs. So that should be extremely fast. So yay. I think that is some progress. One thing that I do wonder about is whether, I know we do have some, can I recap how I did this? Yeah, so essentially, I don't know. I mean, there was just a bug, you know, I think there was just a bug. Basically what it used to do is something that it's almost hard for me to describe. The way that the stats collector would work is that nobody would ever actually start the stopwatch for a particular operator. So let's take as an example this aggregator operator. Nobody would ever start its stopwatch until it called its inputs or something like that. And as an input, what you would do is stop the stopwatch, which is already stopped, by the way, since nobody had started it, so that was already wrong. You would stop that stopwatch. You would do your own work. So you would do all of the work for the hash joiner and above in my example. And then you would restart the timer for the aggregator and quit. So I think you know what it was doing. Oh, this is actually interesting. You know what is precisely what it was doing is it was counting every invocation of the next method except for the first invocation. So what was specifically missing, it was like an off by one thing. The very first time you call next, that time did not get counted. And it just so happens that that's very egregious for a processor like hash joiner, which does almost all of its work the first time you call it. Because the first thing that a hash joiner has to do is it has to read all of one of its inputs and build a giant hash table in memory. So that's going to be like by far the lion's share of the work that it has to do. And then it'll count the time for all of the subsequent calls to next, but that's just not good enough in this particular example. So I think that's basically the bug. Like, and I can summarize it, you know, in sort of a commit message maybe. So, you know, like honestly, the thing that changed is like a really minuscule thing. All we did is we uncommented this if condition, and we always start it the first time. But I mean that it's fixing quite a serious bug, I would say. So let's just delete all of these extra logs. So like, sometimes this happens, by the way, I don't know. Sometimes it happens that like you're chasing this bug and it seems really complicated and scary, and in the end it's like a 3-line diff. That happens to me like all the time. So we'll just add the change, honestly. So we don't need to stage this. We'll stage this, git commit, we'll say call exec, fix undercounting of time in vectorized ops. Previously, the very first invocation of an operator's .next method was not timed. This was a bug that caused confusing results in, well, it's not just confusing, it's inaccurate. Causes inaccurate results in explain analyze, especially egregious for operators like hash join, which do the lion's share of their work on the very first invocation. Do I have all my git commands alias? I have a lot of them alias. I hit git status all the time, so I have that as GS. There's like a couple of other ones. I don't know. You can check out my like, I should probably have like a .files alias. I'm going to make one of those right now, just so that, because people ask about this a lot too. So I'll say commands add .files. My .files live at github.com Jordan Lewis config. So next time somebody asks this, maybe I can just be like, just hit !files. It's a frequently asked question. Does that link work? I think it should. Yeah. All right, so we can get rid of this other change and move on with our lives. So the next thing that I wanted to do is see what happens when we just turn this stuff on all of the time. I'm just gonna do that just for funsies. So basically, where do we set this stuff up again? Wrap with vectorized stats collector. If s.recording stat. So basically, like, what would happen if I just have this thing on all the time? And where do we plumb in recording stats from? It's somewhere above again. Oh, here it is. Okay, so we set stats to true. It's a bigger vimRC than what you've been using. I don't know. I mean, this is just, it's like I spent a ton of time in high school editing my vimRC. And it's stuck with me ever since. I think, yeah, spent a lot of time doing that. No comment. So basically, we just decide whether we're recording stats or not based on whether we have like a tracing span, which is something that it's a little bit unrelated, but kind of related to. It's like you can actually turn on distributed tracing inside of CockroachDB, which makes it so that you can see. Because CockroachDB is also a multi-node system. That's something that I haven't even gotten into here. But you can imagine that, you know, I could be running more than a single node at a time, and a SQL query is going to touch more than one server at a time. And that graph that I've been examining over here, it's going to look different if I have more than one node. It's going to have more information, more edges. And the tricky thing is that in order to transmit the statistics, that one node is collecting to another node, I actually have to figure out a way to serialize that information and pass it across the network. And the way that we do that is we utilize this distributed tracing infrastructure that's given to us by OpenTracing. So anyway, the point is that like we're sort of using this thing in two different ways. Either if you have distributed tracing on, you're going to get this vectorized statistics collection. Or if you just ask for it specifically, we're going to turn on open tracing just to collect that information. So I don't know if that made sense, but that's just how it works. So the question is basically like, what happens if I just say recording stats equals true and then rerun this benchmark? So just get rid of this stuff.
Data banks.
Yo, Nunu is my dad. Thank you so much for the follow. I like that username. So in order to test this, I'm actually not going to benchmark it on my own computer because I think that's just going to be confusing since I'm streaming. It's going to have like bad results. So I'm going to make a new commit for this. Git add one commit. Always turn on vectorized stats collection. I'm going to just push this to Git, and I'm going to open a connection to this other computer that I can use for benchmarking that lives in the cloud somewhere. So I'll do this thing. And while that's booting up, it's just going to take like 2 minutes, but I'm just going to quickly run to the bathroom. So BRB. All right, I am back, and this computer seems to have booted, which is great. So we're just gonna, let's see, we'll cd into our directory here. We'll fetch the changes that I just pushed to Git, like so. I'll check out my selectivity fix branch. What's nice about this computer, by the way, it's really beefy. So I don't have to, like, I don't know, building the database just takes, you know, a lot less time than if I'm doing it locally, especially if I'm streaming at the same time, because streaming does take a lot of resources from the computer. This thing has, like, I don't know, like 16 CPUs. It's pretty beefy. It's got a lot of memory and stuff like that. And what's nice also about it is that you can run benchmarks, and whatever you're doing on your local computer won't, like, affect the performance of those benchmarks at all. You might have, like, noisy neighbor problems, but what are you going to do about that? It's just life in the cloud, right? But I guess the question that I'm just trying to answer is, like, if I ran a simple benchmark, like, the worst case scenario is sort of a query that does almost nothing, because, you know, collecting these stats is not very expensive, but it's sort of like a constant cost. And if the query, like, most of the cost of a query is going to be doing the query itself, but if the query itself does almost nothing, then that constant is going to, you know, creep up in importance in a sense. And, like, if you're running a lot of queries that each take 1 second, you know, collecting some stats for them is going to be almost, it's not really going to make a difference. But if you're
Computers hooked into over
collecting
1,000
stats
data banks throughout the world
for queries that only take, you know, 1 millisecond, then, you know, if the collecting stats itself takes like a quarter of a millisecond or something, that's going to be, you know, whatever it was, 25% slowdown, which is pretty significant. Hey, G Montana 74, thanks for the follow. Okay, so this is all good. Let's make a screen instance so we can have 2 terminals at once. We're going to start a database, cockroach start insecure. We're going to make another window, and we're going to run cockroach workload kv init. So this is that same, whoops, what did I do wrong? Workload init kv. This is that same really simple, you know, 1 table, 2 column workload we were looking at before. The kv workload is what we call it. And if I say run kv and I say read percent 100, percent equals 100, what this is going to do is only do reads. And since there's no database in this, or no data in this database yet, all of these queries are going to be read only. They're going to read no data, so they should be very, very, very fast. So we're running them. It looks like we can do about 53 or 54,000 queries per second. Maybe 60,000. So this little dashboard, the way it works is that the number on the left here, this one is the quote unquote instantaneous number of operations per second that we're doing. And this one here, it's named a lovely name, ops per second cum, but it stands for cumulative and nothing else. This is the cumulative average of all of the operations we're doing per second over time, over the whole run of the benchmark. So it looks like we can do about 60,000 per second. So the question is, like, if I, you know, okay, there's a couple of things going here that I actually have to change. So one thing is that, so this statistics collection, I believe, only comes into play if the vectorized engine is turned on. And there's a separate problem, which is that we don't always have the vectorized engine turned on, because we think that it's only good for queries that need to read a lot of data in the first place. And in fact, it is, because we haven't really optimized it for small queries yet. So I think we're going to have to change the database to always run with vectorized on. That's going to change the performance of this significantly on its own. So then what we really want to do is compare the performance of always running KV with vectorized to the performance of always running KV with vectorized and statistics collection turned on. So we have to do like a little bit of a 2-step process here. So to do that, I think what we do is set cluster setting SQL.defaults.vectorize equals always, I think, or on maybe. Worst case query would have lots of nodes with the leaves doing 1 row per batch, like select where row num mod 1000 equals 0. Yeah, I guess that's fair. So maybe it would be even worse if we had a query that had like a huge number of leaves or a huge number of nodes, and each of the nodes in the query is doing all these timers on and off, but we're doing next to no work. I think you might be right, but constructing such a query, not that easy. And even like there's planning overhead for that query too. So I don't know. I think you might be right, but they're sort of similar, I want to say. So if I set this setting and then I rerun this, hopefully it'll get a lot slower. It didn't, which makes me suspicious. We might need to say always. So 2 is on. So if I say select star from kv where k is equal to 10, that's like, this is an example query that this workload is running. I think the trouble is that like, if I said, yeah, so it sets vectorized to false. I think if I did this by hand and I said set vectorized equals true, so that's like changing the setting for just the session that I'm in. Oh yeah, you know, I forgot we changed the behavior. So I think what we would have to do is set it to this experimental always thing, which means like no matter what, try to run it with vectorized, which like won't work in several cases. And then I run the query like this. That will force it to use the vectorized engine. And in fact, it seems to, I wonder what I did to crash the database, huh? What is going on? Man, I'm just all over the place, huh? So if I set this again, I guess I must have done something to... I don't get that. That's actually slightly concerning and confusing because I feel like this stack trace here, wait. Let's try that one more time. It is, I mean, it's relevant to the stuff that we were just messing with, which is no surprise. So it's saying that when we call output stats.go line 179, oh, I see. So this is kind of interesting. So this has to do with what I was saying earlier about how when we collect these statistics, we rely on this thing called open tracing in order to sort of send the statistics about execution all around the cluster. And the thing that we're trying to do is actually something a little bit different. We're not really trying to send the statistics necessarily everywhere, right? We're just trying to kind of count the where are we? You know, it's kind of a question, right? It's like you could imagine that we would sort of increment various counters on the nodes local to where work is happening. That's sort of one way of doing it. Or you could imagine that we are always sending back this information on tracing spans, you know? But then that would require like open tracing to always be enabled, which is suspicious. You know, I mean, this was a question that we asked early on when we were setting the system up, which is like, do we want to send these statistics back via open tracing or do we want to use like a different protocol? And I almost think that doing it via open tracing was wrong because we have this whole other protocol that we can use to send metadata about queries around the same execution path. And I just don't know why we didn't decide to use that method. It seems like a little bit more straightforward here. We wouldn't have to care about whether we have stats on or off, or excuse me, open tracing on or off. So the reason that we're crashing right now specifically is that like we just told it to always be collecting stats even if tracing is off. And so when we try to actually do something with tracing, it blows up because we didn't turn tracing on in the first place. Anyway, so I mean, I feel like it kind of comes down to like whether we want to keep track of performance statistics on a per node basis or on like a per query basis in the gateway. That's like a hard question to answer, honestly. Like if we think about that the pprof, what pprof does that we were looking at earlier. So this diagram over here, this diagram is like explicitly local. It's about like what CPU time is being used on the particular node that you asked to get a CPU profile from. It's never going to contain information about remote nodes ever, just because that's how pprof works. And that is still a valid view, but it's like a little bit less interesting. I feel like ideally what you would really want to have is a picture of the entire cluster, maybe. At least you would want to be able to have all the information and be able to filter it. Like you would want to say like, you know, for all queries across the whole cluster, you know, which are the nodes that are experiencing the most CPU usage or something like that. That's the kind of question that you really want to be able to answer with the most powerful end system. And I guess in order to do that, you really do need, I want to say that you really do need to send back the distributed statistics in a sense. And so we need to have either tracing enabled or use this metadata method. Tricky. I think, I mean, just out of curiosity, I think there's this thing called, what is it called? Like metadata emitter or something like that. Look at how we do this. So I know that, okay, so let's actually go ahead and look at that, you know, what is it called? Call batch scan. So this is like the implementation of that table reader thing that we've been looking at over and over again in our other graph. It's like this box here. It's implemented by this thing called call batch scan. Call batch scan, here's its little, you know, method, its next method that we've been talking about over and over in case you were curious. It just delegates to something else, but in any case, this is where it happens. It returns this batch. But it implements this other thing called a metadata source. And in order to implement metadata source, you have to have a method called drain meta. And if you have a method called drain meta, then it allows you to output metadata about your execution. And so now I'm kind of wondering whether what we really want to do is output these stats via this metadata, in which case we could do all of this stuff in a really efficient way without having to ever involve tracing, which is a whole mess and requires editing, you know, the Go context and stuff like that. It's like, it's kind of like an overcomplicated framework, I think, for doing what we want to do. So I almost think like maybe we should just add drain meta implementation on top of this stats collector and see where that gets us. I'm going to try that out. We'll see what happens. So we'll say func. Actually, you know, we could just use Golang magic to do this. We'll say, we'll just hit option enter. We can do implement interface and we can pass in metadata source. I don't know why this is slow. There we go. So now we've got our drain meta little stub implementation. And what it lets you do is output a slice of thing called producer metadata, which has some information that we can add to if we want. And I think we do want to be adding to this struct. And what we could add is essentially that, you know, that stats struct that we've been talking about. It's a protobuf, but we could just add a pointer to it, right? So essentially down at the bottom, we would say like, you know, stats. What do we want to call this? It's not just stats, right? It's like execution stats or something. Execution stats. This is going to be a pointer to vectorized stats. Like so. And then presumably like somewhere, somebody's actually looking at this thing and turning it into something that we can, oh, only one of these fields would ever be set. If this ever changes, note that there are consumers out there that extract the error. I'm actually a little bit confused. Like, isn't this thing also a protobuf? Like, where do we, I feel like there's gotta be a producer metadata. Oh, it looks like maybe we serialize one inside of into the other or something like that. So we would also be adding to this, right? We would also be saying message, you know, execution stats. This is going to be optional. And then it's going to be our vectorized execution stats or whatever. What was it called again? Vectorized stats. Vectorized stats. Or do we even need to define a message? Couldn't we just... I don't know why everybody's defining sub-messages here. You could also just say, like, execution stats, or rather, vectorized stats, execution stats equals 10. Doesn't sync. Does it not have a reference to this yet? Oh, this is exec infra PB and this is exec PB. I wonder if we're gonna have like an import cycle issue in our protobuf definitions. Definitely possible. Maybe not. No, nobody. This thing doesn't import anything scary looking. So we could probably just import exec PB from exec infra PB. Feels like slightly backwards, honestly, but. So in our data.proto, what we'll want to do. I don't know why this is red, by the way. I feel like this is just something wrong with my IDE setup. It's hard to get the IDE and the protobufs to sort of work well together on the whole. So we'll just say import exec pb slash stats.proto. Does that not work? Maybe you have to say, you have to put the whole path maybe? SQL call exec. Okay, that worked. And then hopefully at the bottom, I feel like this is probably just like kind of unhappy for no reason. And if I call make protobuf, it will sort of inflate properly. Let's try that out. So this is invoking the protobuf compiler. Okay, it is extremely unhappy for some reason. Oh, that makes sense. So it's like this, all of these things import this top one, and this top one didn't work, so all of these things failed. But that's fine. I think it's just like a single error to fix, basically. And it's probably just that I misnamed this or something like that.
The computer's hooked into over 1,000 data banks throughout the world.
Yo, Frosted Donut, thank you for the follow, my friend. Oh, is the problem that I just didn't? I need to put the namespace, obviously, so it needs to be exec pb.vectorized stats. Okay, so that's gonna work. Now we can recall make protobuf, and hopefully this will all fall into place. Okay, call it. Solid. The next thing that I need to figure out is like where we actually turn the in-memory equivalent of these remote producer metadata thing into the actual remote producer metadata. I don't quite understand why they're not the same. It's like a little bit suspicious, honestly. So here's these message types, and presumably we like edit them somewhere. I guess the question is not whether this thing is used anywhere, but like where it's... Yeah, this thing. So like where do we set this value? Local meta to remote producer meta. Okay, so we just have this like giant disturbing looking switch statement that we sometimes call. Okay, that's fine. I don't love it, but that's fine. We'll just add another case for this. We'll just say like else if meta dot execution stats is not equal to nil, rpm dot execution How come there's only a get execution stats? Oh, rpm.value, I see. rpm.value is equal to remote producer meta data. No, this will just be meta.execution stats like that, right? Why, how come this doesn't work? Oh, does one of require you to have this weird struct thing? I feel like that's the issue. This is a remote producer metadata value. Oh my God. Protobuf is annoying, you guys. I have to say, I don't really understand what I'm doing here, but this is certainly kind of a pain in the butt. Maybe it will automatically have generated me one though. So remote producer metadata. Yeah, it does. Okay, so it did actually generate me one of these things already. So that's fine. So execution stats is pointing to this meta.execution stats. All right. So that's set up. Now, the only thing that we would need to do next, not the only thing, the next thing that we would want to do is set up how this drain meta thing is going to work at all. Hey, XMessage, thank you for the follow. And what we'll want to do is we'll just want to say, when we get drained, we're going to return, I mean, it's straightforward. We want to return a slice. So well, I mean, it's a static slice always of one length, I think. So we'll say return exec infra pb dot producer metadata. And it's gonna be
computers hooked into over 1,000 data banks throughout the world.
Yo, Trev1, thanks for the follow. When I try to make a query, the optimizer outsmarts me. Yo, that does happen. What were you trying? The optimizer is like kind of smart. It's a little bit scary, TBH. And so the thing that we're going to have inside is the execution stats is going to be pointing at the VSC dot stats. Where is it? Vectorized stats. And I guess this is going to have to be the address of, because this is all expecting pointers. Honestly, this is okay. And then, is that all we have to do? Does this thing get called multiple times? That's another question I have. Like, when do we call this drain meta thing? Somebody else is asking me this. I think that there's a selection bias. That's what I was saying to the other person who was asking this question. It's like people only are going to put a camera on their keyboard if it's like weird. So it's like you only see streamers with keyboards on their stream if they have a weird keyboard in the first place. So then it sort of adds up. But you can hit this guy for more information. It's funny though. How's it going, MR King? I hope you're having a good day. So if I go back to this call batch scan, which is my original example of drain meta, do we have to worry about this thing getting called multiple times? I don't actually really know. Like, what's the contract of this thing? Drain meta returns all the metadata produced by the processor or operator. It will be called exactly once. Okay. Okay, cool. So that's simple. So we're just going to return our stats. And then let's see. So the next step would be for me to try to figure out, like, when I pull this metadata, which is going to be at the very top, that's sort of when I'm going to want to do the work that I used to be doing by pulling it out of the spans and whatnot. I try to make a long chain of nodes where each node produces one row per batch, but it converts it into a simple query. I mean, an easy way to do that, you could just like do a long chain of unions, which is what I was doing before. If you make a table with a single row, and then just say select star from table, union all select star from table, union all select star from table, and copy and paste that like a million times. That's like kind of what you want, I think. I feel like that might work. I don't know. Try that out. So I'll say drain meta implements the metadata producer interface. Metadata source, rather. No, like I said, look, I wrote a blog post about this. I don't know. Look, the reason that I have a camera on the keyboard is literally just for fun, just because it's hilarious, because it provokes people like you to be outraged. It's just because I have an extra camera, and I think it looks cool. I mean, come on, look at this shit. We can have a typing race if you want. I'll crush you. It's like you got to track your APM, you know? It's like, I know I'm not playing StarCraft here, but like... I don't know what to say, man. I can't justify it. It's a total goofy thing. Total goofy thing. So we're also going to assert that not only we call exec base.operator, we're also going to assert that we are a metadata source. Exec infra pb.metadata source. All right. So let's try to take a look now at where we process this metadata, because that's something I don't exactly remember. It's kind of this. It's like, who's calling this next stuff, and when do we... When do we end up using this metadata that next sometimes returns? This is, by the way, like, it's a little confusing for sure, because there's like multiple next interfaces going on in here. One is sort of like a, it looks cool, but my headcanon is that you guys are self-conscious about people not believing your... That's a good headcanon. It doesn't match with my headcanon. It doesn't match with my reality, but I like that you exist, and I like that that's what you think. This moving between object functions in different files is pretty sweet. Yo, if you couldn't do that, like, I don't even know where I would be right now. I would be lost. This project is just so massive that, like, if I didn't have this, I would be out to absolute sea. If I look, I mean, here's another thing. Like, if I'm doing a little baby project, I don't like necessarily have to use this huge IDE. It's just sort of in the case where
Computers hooked into over 1,000 data banks throughout the world.
That stream alert sounded really messed up, but thanks for the follow, Mr. King. VS Code. Okay, yeah, I think in VS Code, like, it probably has this stuff. If you like search for usages or something like that, like VS Code probably has a search for usages button, and you can, it'll probably give you links to things in other files. That'd be my guess. If it doesn't, that would be pretty weird. All right, so I lost my train of thought, but what's confusing about this is just that, like, there's two kinds of iterators in the system. One is the batch mode of iteration, which is what we've been using so far, and the one that does the stats output. And then the one's that sort of original row at a time output, which is the way that you can get the metadata. So the thing that I need to do is figure out, where do we do like the very root of this computation? I think it might be this drain helper thing. For example, so here's an example, right? This is where we get a metadata bit, and, well, no, because I think what we're doing here is we're just passing along most of this metadata. So this can't be where we actually process things. Maybe what we could do is search for where we use, for example, this ranges information. Right, I think this is the top of the funnel. This is called, no. Okay, before I say anything else, I'm just gonna keep lying if I don't get it right. I feel like I'm just lying over and over again. Why would it be? No, I actually think this is right. Okay, so here's what happens at the very bottom. So this is something I haven't quite explained yet, but so if you go to the very, like, if you imagine you're the person at the bottom of this query in this graph here, right? I've been saying over and over again, like, well, what do we do when we're calling next on one of these nodes, like higher up in the graph? But you can imagine that, like, at the very end of the query, what we call response here, there has to be some logic for how to, like, turn the rows that we're processing into actual results for the user. And that's what gets taken care of here. This push method is what does all of that. And what this is doing is it's given a row from that bottom operator, so from the aggregator in this particular case. And the job of this push thing is to actually send the row all the way down to the user. And it does that in a sort of a Byzantine way that's a little complicated, but I think this is also where we would do any kind of final processing of metadata. And you can see that in these examples, we do some processing on, for example, this ranges information, which the idea of this ranges thing, this is actually kind of neat, and it has to do with when we're processing data on multiple nodes at the same time. Essentially, and I haven't done an example of this yet, and I really should. So I'm contemplating whether I should just pause for a second and pull up an example of what this is going to look like on multiple nodes. I'm going to do that because I think it's really worth it. So I'm just going to run cockroach demo here, and I'm going to pass in this nodes3 argument, which is going to set up sort of like a fake 3-node cluster. So I'll make a new database. I'm going to make a table, A int, B int. Just watching you do this is so cool, but it also makes your head hurt. Can't believe you're learning all this in college. Yeah, man. I guess you're getting a CS degree. That's super awesome. I hope you have a good time. I think college is a fun place to learn about programming. I will say that, like, you know, I've been working on this stuff for like quite a number of years at this point. So what's second nature to me at this current moment? I mean, obviously you can see me struggling. That's one thing. So even though I've been working on this for years, we all struggle. And also, like, if it looks intimidating, you'll learn this stuff little by little. So like, don't worry about it. You got this, is my message to you joining college soon. So let's insert some data into this table though. Actually, wait, hold on. Before I do that, I need to actually give it a primary key. So I'm going to drop table. I'll recreate it with a primary key. Like so. I'm going to insert a bunch of data into it. So I'll say insert into A, select stop. I'll also do select G, comma, G+1 from generate series 1 to 100,000. So I'm going to insert 100,000 rows into this table. And they're all going to have, like, I'll show you what it looks like. Just the first 3 rows look like this, like the primary key is 1 and the other value is 2. It's not important what the data is, just sort of for the purposes of this demonstration. Okay, so then the next thing that I need to do is, since I do have like sort of 3 nodes in this cluster, I want to distribute the data across the 3 nodes. Normally, like in the course of running a production database, this is just going to happen automatically via CockroachDB because it kind of splits the data based on the amount of load that a particular part of the table is getting. We call that load-based splitting. It's kind of neat, but we don't have any load in this database, so we sort of have to fake it. And the way we can do that is just introduce sort of splits in the data ranges using this alter table split command, I think it's called. So alter table split at values. And if I give it a couple of random values, like maybe 300 or 30,000, 60,000, and 90,000, that's going to give me, whoops, I didn't put the name of the table. I also did it wrong, I guess. I think it's got to have parents like this or something like that. I always get this wrong. All right, so this is going to give me 4 ranges that the table is split up into. So I can figure that out by saying show ranges from table A, I think. And as you can see, there are 4 rows in this output. And what this is telling me is that I have 4, this table split up into 4 chunks. And the leaseholder for each of these chunks is all 1 right now, which is also unideal because really we want to scatter these ranges on different leaseholders. Only, and what leaseholder means just that, like in the context of CockroachDB, the distributed database, fetching data requires that you go to the leaseholder of the data. Because if you don't do that, you'll have out-of-date data. That's sort of just like part of how Raft works, which is the distributed consensus algorithm that we use to make sure that all of the data is consistent and up-to-date at all times. That's sort of a tangent. I won't get into that, but it's really, really cool. But in order to scatter the leaseholders of these ranges, I can use alter table scatter, I think. And then if I do show ranges again, some of them are on number 1, some of them are on number 2, some of them are on number 3, etc. So finally, if I now do another explain, analyze, or I'll just do explain in this time because I don't need to actually, well, I'll do explain analyze. So I'll say explain analyze, select star from A, join A. I guess I'll have to alias this A1, join A2 on A1 dot B is equal to A2 dot B, maybe. So check this out. The complexity has been up to the next level. And you might be thinking like, what the heck is going on here? And the reason that it's so much more complicated than the original graph that we were looking at, which is this one, is that we now have data on all 3 of the nodes that we need to collect in order to do our work as, you know, a SQL join processor. And so you can see that these colored boxes here, this blue one here, this sort of pinkish one here, and this other blue one here, these all represent different nodes in the cluster. And on each of the nodes, we're doing sort of the same thing that we were doing on this simpler one node example. We're fetching all of the data for this table. And in particular, in this case, we're only fetching the part of the data for this table that the node owns, so that the node is a leaseholder for. And then we do this other thing. We sort of shuffle the data by hash across the cluster so that the hash joiners can kind of do their work in a consistent way. And then finally, the hash joiners all run and then stream their inputs to the gateway here. But sorry, the reason that I even brought any of this up is just to say that when we're collecting these vectorized statistics, so in this case, you know, we had 30,000 tuples outputted from each of these tables. There was no amplification. You know, we did stall time. The way that we actually propagate the statistics across this kind of flow graph in the cluster is via this metadata. The metadata gets serialized to protobuf, and it all sort of pours down into the end and gets sent to the client. Is that what I was trying to say? I kind of forget what my point was with all that, but oh no, I remember what it was. Okay, I was explaining like what is this ranges field in this producer metadata? Like why is this something that we care about, and what is it exactly? What's kind of cool is that you can imagine that like halfway through a piece of execution, you might actually have the wrong idea about what the leaseholder is for a particular chunk of data. So for the chunk of data from the 0th key through the 30,000th key, which is the part of this table that node 1 owns in this particular case, you could imagine that like that data might change leaseholders to live on node 3, just if it got split or the data moved or node 1 went down or anything like that. And so this ranges thing is actually going to tell the gateway to update its estimates of where or I wouldn't say estimates, it's like update its cache of where a particular range is located, so that next time when we replan the same query, we can have a higher likelihood of getting the information correct about where that data lives. If we don't get it correct, everything's going to still work, because like, for example, if let's say I was trying to read the first 30,000 rows on node 1 and the data actually lived on node 3, it's like going to be fine, because under the hood it's going to like forward that request to node 3. It's just less efficient. Ideally, you always want to be planning these table readers on the nodes that are the leaseholder of the data that the table readers are trying to read. Okay, blah blah blah. What an explanation. Why did I even go into that? Just because I think it's cool. I think that's fundamentally the reason I wanted to talk about this, because it's kind of awesome. It's just like a pretty neat system how it all fits together. Right. So back to where we actually process this range information, right? This is what I was talking about. We take the information from this metadata ranges thing and we insert it into something called a range cache, update our estimates, etc. Yo, Bantu Caravan, thank you so much for stopping by. I appreciate you. Have a great rest of your day. We should hang out soon. Okay. So what I'm going to want to do, I guess, is try to process these sort of stats in a different way than we're doing before. Now that I've got access to it via metadata and not via the trace, it's sort of like figure out how to process meta.execution stats. I think in order to figure this out, to be honest, I need to figure out how we were doing it before with the tracing method, because I don't even really quite remember how that's done. I mean, to be honest, I think the way it works is that this metadata also contains trace data right here. And what we're doing is we're propagating the trace data into sort of like the local context spans. Since in Go, the way that open tracing works is that it attaches the tracing information to this like context.context object, which is the thing that we're basically everything in Go is going to take a context, because it's just a convenient way of stashing information like tracing or log information or stuff like that. So we sort of append the trace information onto this context thing. And then I suppose somebody else down the line is the one that actually extracts the data from the span. I'm not sure where that happens. I remember we were looking at it earlier. What was it called? It was called like diagram stats or something like that. Generate plan diagram. I think this is right. So who calls this? No, this is not quite right either. Where I just don't remember where that thing is where we actually pass in like the statistics and stuff like that. How can I find it? How can I find it? I think if I go, I know, if I go to vectorized stats, the struct, which I think lives in data.go, I think it's got this stats method on it. Wait a minute, not this data.go, the other data.go. Unfortunately, there's two. Where the heck is that thing? Guess I can search by symbol. Vectorized stats. Stats.go it was called. So I think there's this method called stats? Output stats? Yeah, this guy. So who calls this? This is sort of the thing that we need to be thinking about. Finish vectorized stats collectors. Oh, there's like a callback. That is kind of complicated. So we have this thing called a metadata sources queue. And we're adding to it a new kind of source with a callback. I'm confused. Drain meta callback. What is this? Callback metadata source. Oh, interesting. I guess the way that what this is doing is like it's kind of putting another stats collector, another metadata source at the very bottom of the flow. And when you invoke it, it outputs stats to trace. I guess this is actually not quite what I was looking for, because unfortunately, this is just actually connecting the stats to that kind of context trace that I was talking about before. What we really want... Oh, I see. So this is the equivalent of us outputting it in another metadata package. So this is sort of like, this is sort of obviated at this point, I think. The main difference, I think the main thing that we actually want to be doing is seeing, again, who uses trace data and how do they piece it apart.
Data banks.
Hey, Atia, thank you so much for the follow. I really appreciate it. It's sort of like so sure, we get this trace data from the metadata, and sure, we import it into this open tracing span. The thing that I don't understand is, when do we like extract out the statistics from those spans into something that users can actually see? That's what I'm really missing right now. And maybe it's actually inside of explain, since we only actually invoke this whole mess during explain analyze. Maybe it's actually all of this stuff
hooked into
happens
over
just
1,000 data
in a
banks throughout the
single
world.
part of explain. Yo, Emma Dashi, thank you for the follow. Yeah, you know, isn't it this? Isn't it this? So if we're set up to do analyze, we create an open tracing span. We do all sorts of stuff with is recording. We start a span. We set up a tracer. We start recording. We do our thing. We finish the span, and then we just extract the spans out again. I see, and then we call this diagram that adds spans. This is kind of the key. This whole thing right here, I think. Yo, JBoney7, hello to you, my friend. How you doing? So I think like ultimately what we really want to do here is figure out a way to change this add spans thing to, instead of taking a slice of recorded spans, to take a slice of vectorized stats. What is Golang? Golang is a programming language by Google. Do I have a command for this thing? I guess I don't. Golang does not exist. I should really set that up to work, right? But you can check it out over here. It's a programming language that's meant to be kind of like a modern systems programming language for doing things like, well, really anything, but specifically like microservices and distributed systems is where a lot of people like to use Go these days. What I'm working on is a database, which is kind of like it's more of like a macro service in a distributed system, but it's a garbage collected language. Oh, Go. Yeah, exactly. Wow, you really like caps lock, huh? My recommendation to you is to turn off that caps lock, little buddy.
Databanks.
Thanks for the follow, man. Okay, so let's see. No worries. I think that it's kind of like going to be a little bit hard to make this all work.
Databanks.
Gulen31, thanks for the follow. Capsock all everywhere today. You guys are wrong about that, I'm afraid. You guys are so wrong about that. Let's read it what add spans actually does though. When we run extract stats from spans, what do we actually do? What we do is we end up making a map from integer to slice of string. And I see. I think that, I mean, this is kind of complicated, but honestly, if we do this transformation where we just include the stats directly on the metadata as protobufs, I do think it's going to simplify a lot of this stuff. I think it's kind of a big refactor, unfortunately. So this stats for query plan thing, it just gives me back a slice of strings. And what I'm doing is that I'm trying to add these slice of strings to a list of other strings for a processor with a particular ID. That's what's going on here. Yo, Fruit Cup. I'm afraid I have no idea. I'm also nervous that my stream just lost its connection, huh? Maybe not. Maybe there was a brief blip there. Looks like we're maybe back. I don't use Visual Studio Code though, so I don't actually know how that works, I'm afraid. Yeah, okay, look, you guys. Didn't mean to do that. Yeah, there's a little lag for a second. To be honest, you guys, I'm running out of steam. I know that I need to be doing this refactor, and I think that this refactor is the key to getting to the point that we want it to be, to have the stats on all the time. But I don't know if I can do it today. I'm getting a little tired, getting a little hungry. And being tired and hungry is not a good recipe for programming. You probably know this already, but I'm telling you it if you don't know.
Computers
so I
hooked
think I'm
into
gonna
over 1,000
probably
data banks throughout the world.
probably gonna cut the stream for now. Yo, Abdunio, thank you for the follow. But before we do that, I just wanted to thank everybody for all the follows and all the love and all the watching today. I think we had quite a lot of people join the stream today, which was really fun. I had a great time hanging out with you guys. And you know, do send me a follow if you haven't already. I'm gonna stream every Friday and most Sundays, most Sunday afternoon. We do a lot of database projects like this. We do other Golang projects like this. So if you're a Golang person, you're interested in getting into Golang, this could be a good stream for you. I'm gonna go ahead and find somebody to raid now. And hopefully we can send somebody, our viewers. Be kind to them, whoever they are. Oh, my friend Jean is a programming language researcher. We actually rated her once before. Let's rate her again because she's doing a cool Q&A. So we're gonna do that. So we'll say raid Jean QA SOAR like this. And so say hello. I think they're doing like an interview thing. They're talking about different programming languages. I think it's a pretty cool thing. They were doing it, I think, a couple weeks ago as well. So say hello. Enjoy the rest of your day, you guys. And I'll catch you next time. All right. All right. Bye-bye.
But in practice, it's cool. It's totally fine.